already. Looking very good there. I just want to share my screen and show you where we're going to go. Yep. Just making sure ensuring you get the right road design note. So make sure you go to the VicRoads website to get the road design note. And it's in here, business, industry, technical publications, road design. The reason I say that is if you Google road design note 0604, you actually get our website, because we wrote a little article on one of the updates, and it seems to have jumped over the Victorian government's website. So, but that's an old article. So make sure you actually go to the VicRoads website. We're going to take ours down because we don't want people getting an old one, and ours was just to inform of a new one back in the day. That makes sense. Anyway, and so in here you've got your supplements to the Austroads guides. You've got the road design notes, and that's where you're going to go. This accepted safety barrier products thing is just a little statement about where you get stuff, and the fact that there's not product data sheet, detail sheets much anymore. But you go into road design note, and you've got lots of different road design notes, and there's some great ones associated with barriers. Central barriers and narrow medians is a good one, and a few others. But you go down to 0604 there, and I'm sure many of you did this, and you open up 0604 there, and it's this one. September 2021 is the current one. And then within that, and I'm sure you all found this, you then go and you find the products that you're interested in, and then you click on the hyperlink there, and you'll get the technical conditions of use, the Austroads technical conditions of use. So that's the process for doing it, to ensure you get the latest. And I really do stress that every time you use it, go into the VicRoads website and download the latest version, because even like version 18 to 19, there was no announcement. It just seems to have happened. So, you could be happily going along, and there could have been some change in which barriers are accepted, some slight tweak in something for some reason or another. So make sure you do that. That was just a little something I noticed. Any questions on your assignments or anything from the last session before we get started on a bit of stuff today? Pause there. Remember, you can always pop your hand up, and we can then give you the ability to unmute yourself and have a chat with us. But if nobody wants to kick things off, so what we've done is, trying to pack a lot in. We packed a huge amount in our last session. This session's not trying to pack as much in, and we've moved some quizzes around, and so you will have your break. No quiz required during your break, which we will have at somewhere around 10:30, and there is a quiz to do, but you can do that at the end, and that'll be the completion of this course, as long as you've completed your assignment. We do have a good bit of time allocated in this session to have answer individual questions. Jamie is going to present some stuff, and I'm going to present some stuff first, but then it's really over to you if there's anything you want us to explore. You've got particular problems, there's particular products, there's challenges out there, philosophies that you would like a bit of discussion on, and we can unmute you, and you can sort of have your say or put your point forward, or ask your question live if you want. I've got a couple of things are coming in here. Are Austroads requirements always more conservative than suppliers' specs? That's an interesting one. Jamie, I might need to get you to have input on that. I think generally I'm going to say about the same, but Jamie, any comment on that?
Yeah, occasionally they are more conservative. Austroads relies purely on crash tested, evidence-based outcomes. Occasionally the suppliers might interpolate, deflection requirements, for instance, at different speeds based on theory, basically. So usually they're consistent, but on occasion the suppliers might provide some additional information or guidance on things that they might have determined themselves.
And so with that, Jamie, and you do a bit of this also, isn't it? When in the real world out there and there's barrier installations and you can't meet TCU requirements, or, there's bits and pieces, you'll often go to the manufacturer to have a discussion about the performance of their product from their modeling and their, what they know about different things, and then sort of document a design exception based on that as your risk mitigation measures. Is that right?
That's right. The suppliers can often provide you some additional information that's not captured in the Austroads TCUs. It might be around deflections at different speeds, and they can even guide you. The suppliers might ask you, what's the cross section that you're dealing with, and what's the speed environment? Is there a curve or not? And they can think about what sort of likely maximum impact angles and the worst case impact conditions might be. And based on that, they might say, well, in this situation, you might expect a deflection around X, which may be less than the crash tested deflection, which is based on those high speed, high impact angle situations. Also around reduced post spacings, that's another thing that the suppliers might provide you some advice around that, how to do that, and what the resulting deflections might be.
Good. And Joseph sort of asking, so is this just captured in a design exception report, is it?
You might do a design exception report. Look, it's typically not. Typically it'd be a fairly localized treatment. It's not typically. It's probably not really a design exception. That said, if you are compromising on deflection requirements, you would need to document that. And if you had something to point to from the supplier saying that this is an acceptable sort of outcome, that might be sufficient.
Yep. But you want to, I suppose there's a few things on that. I mean, we do sometimes see people who look at the requirements and they can't be met, and then their response can often be I suppose like, we can't put barrier in, and there's trees, and we can't get the deflection, and then it's either we chop the trees down or we don't put the barrier in, and it's not like that. You can work with the product and the knowledge of it and tightening up post spacings and maybe going a little bit beyond and just understanding that risk and balancing it out and making, as Jamie said, some documentation around that, because it's not like at deflection space of 2.9 meters it's completely safe, and 3.1 meters it's completely unsafe. It's these crash tests, and that's the distance and knowing a bit about that. But I think that there's a bit more to that. A couple of other questions coming. Ritu is asking, how many more quizzes do you have to do? You've got one more quiz before you successfully complete the course, which is based on the content of Jamie's first session and my short session on motorcycles and barriers, and that's all. There was a little bit of questioning around the way that the system does the quizzes, which is essentially that you can't change your answer, and you have to submit your quiz and then you get another go at it. So it's probably a little bit annoying as you see you've done something wrong and then you can't change it until you submit and then have another go. But it is what what it is. Do you still count wombats? Yes, there are some Wally the Wombats appearing in this session. So you can't do your barrier designs while the course is going on. You've got to keep an eye on what's actually being presented. And there's a few of those to keep an eye out for. This morning's session has a bit of theory in it again, and the first session. The second session this morning is quite a lot of real world challenges, stuff ups, bad things that have happened out there for you to learn from, for you to note. So there's quite a lot of pictures and real world examples, which are really, really helpful, and people really enjoy those. So we'll get into those. What else have we got in here as questions? How do we get to the web area that I was just talking about? Okay, so that is on the Victorian government website, VicRoads website. And I'll just share my screen again in case anybody missed that. So it's vicroads.vic.gov.au and it's within business industry technical publications, road design. That is in Evan's presentation, the pathway to this. And then within that, you've got, a lot of your technical road design, well, all your technical road design for Victoria specific. And you actually, instead of going to accepted barrier products, you go to road design notes. And then 0604 is the key document there. And that will then feed you through to the other ones.
I'll just clarify my comment quickly on design exceptions. Look, if you are doing something that goes against or doesn't meet the Austroads TCUs, that probably is a design exception as far as barriers go. And you would want to document it. And in the list there that Ken just showed, you may have noticed there is a road design note around design exception reports. So you may want to take a look at that.
Okay. Okay. I think we've covered off everything everybody's put in, but I will, as per usual, be in the background answering questions and then feeding ones to Jamie if required for different discussion. Have a think about any particular sort of topics you want more discussion on, you'd like to sort of put forward something. And as mentioned, after we have the break and in the after break session, we're going to give some time for that discussion. I've got a few other things that if we get time, we will delve into, a few examples, a few things, but we certainly want to make it available for you to direct into particular areas of interest. And I know some of you have got some really strong areas of interest, as we talked about, around maintenance, around environment, around constructability and things like that. So a few areas that people might want to delve into. But enough out of me. Over to you, Jamie. Let's what are you going to talk about? I need to let you
yes, please.
Let you actually share your slides. There we go. Hopefully that's good. That seems to be working quite well there. We can see the overall screen. Now we can see presenter and we can see your mouse. Yep, there it is. Beautiful. Right. Okay, over to you, Jamie.
Thanks, Ken, and morning all. I'd like to start off today giving you an introduction, and I will stress it's an introduction to barrier design. I intend to touch on the key considerations around barrier design. We won't have time to go into a huge amount of detail on each of those, but if there's something that is not covered, please do ask questions as I go through. So the key references, again, when it comes to all things barriers, are the Austroads Guide to Road Design, Part 6, the DOT or your State Road Authorities supplement to the Austroads Guides to Road Design, which do take precedence over the Austroads Guide. Now, DOT in Victoria, more than any other state, has a lot of specific guidance on barriers, which is great. It really does guide practitioners and clarify a lot of things, but you need to know it's there. and you need to know where to look. So DOT has a suite of standard drawings and guideline drawings, road design notes. We've mentioned some of the key ones already, 604 with the accepted safety barrier products. The remaining barrier design guidance, a lot of it has been consolidated into 0616, barrier design commentary. Previously, there were two separate RDNs for the use of guard fence and the use of wire rope. So all that good information plus more has ended up in 0616. On occasion, you may want to contact the suppliers. 0604 does have links to the Austroads TCUs, technical conditions of use, and for some products, the VicRoads or DOT detail sheet, but it does provide a limited amount of information. If you're dealing with a particularly tricky situation, you're highly constrained, or you need to do something a little bit different, you might want to contact the suppliers. They might provide you some extra information that's not available in those documents and be able to help you through those tricky situations. There are additional technical drawings. You can freely access the product manuals. You can get on the phone and talk to the suppliers. They have some technical support people that really know their products in and out and can help you through those tricky situations. First thing you need to think about when you're commencing a barrier design is what's the function of the barrier that you're looking to design. And you can see a range of different possibilities there. We might be installing a barrier at the roadside, a longitudinal barrier that is purely intended to shield hazards from errant vehicles. So we're concerned primarily about that runoff road crash. The barrier typically would only need to be able to be struck safely from one side, as opposed to a medium barrier, which is intended to prevent those cross carriageway crashes. It must be able to be struck safely from either side. In the case of bridges, the primary consideration, the worst case situation is that a vehicle, and perhaps a heavy vehicle, penetrates that barrier and ends up on whatever is below the bridge. It might be in a waterway, it might be a railway line or another roadway. So the potential secondary event is perhaps of higher consequence than that single vehicle departing the bridge, and we beef things up to a higher containment level. At work sites, we typically have reduced speed limits in place. We have a different range of products at our disposal, and the intention of those is to shield the work site and any workers working behind the barrier from errant vehicles, and perhaps protect the occupants of those vehicles from drop-offs or other things that might be present within the work site. Now, Evan took you through the different products the other day. Longitudinal barriers we break into a number of categories based on how flexible or rigid they are. And I will revisit that just to sort of reinforce some of the messages that Evan put forward the other day. Any longitudinal system must be terminated appropriately with either an end terminal or a crash cushion. We do occasionally use point protectors, and any of the above may be a permanent or temporary installation, or it may be a permanent or temporary product. We do group our products by permanent systems or temporary systems, but often the question is asked, how long does something need to be in place to be a permanent system? Sometimes permanent barriers are installed in a temporary situation. Now, rigid barriers, typically concrete, perhaps with a steel extension, as you can see there. It depends on the containment level that we are looking to achieve. There we have concrete barriers on bridges. That's the Balti bridge at the bottom. So we really do not want a heavy vehicle to penetrate that barrier. and end up in the drink or on the ground beneath that bridge, which is a very long way down. So they're particularly useful in these urban environments where we're constrained, we have a narrow median, and a lot of heavy vehicles. These barriers deflect by very little, negligible deflection, which has its pros and cons. On the upside, there's very little, if any, damage incurred to the barrier, which means that from a maintenance point of view, they're great. They can sustain many impacts without needing any intervention. They can contain those larger vehicles. You can design a rigid barrier to contain as large a vehicle as you want. On the downside, they have a relatively high impact severity compared to other systems. So with that in mind, you should avoid using them in locations where you might impact the barrier at a high angle. So in a fairly sort of constrained environment, where you've only perhaps got a few lanes of traffic, generous geometry, and there isn't that opportunity to work up a severe impact angle, rigid barriers are often the way to go. Stepping up in terms of flexibility, we go to the semi-rigid barrier category. On the left, we have the old Type B guard fence. I say old, it is still accepted for use, but it has been significantly downgraded. It was always deemed to comply at test level 3 without being tested. Some testing was undertaken a few years ago that showed that it didn't perform nearly as well as we would have liked. So it has been downgraded to test level 2, which is, so it's suitable for use at speeds up to 70 kilometres per hour. So the use of the old Type B guard fence going forward will be significantly reduced. On the right-hand side, you can see a Thri-beam installation, which is a stiffer barrier, able to contain some bigger vehicles, but still within that semi-rigid category. These systems have low deflections compared to flexible barriers, at least. They deflect by some amount, perhaps in the order of 1 metre. And because of that deflection, they are somewhat forgiving and more forgiving than rigid barriers on the occupants of errant vehicles. They typically remain serviceable after impact, unless the impact is particularly severe. Most impacts with semi-rigid barriers are shallow angle, minor impacts. So there's a bit of a dent in the barrier often, and that's about it. So they live to see another day. They can easily be transitioned to rigid barriers directly connected, which is a positive. And compared to wire ropes, at least, they can be applied in some constrained locations. So if you've got tight curves or a really constrained area where you can't fit a very long barrier, a semi-rigid barrier might be the way to go. Flexible barriers are certainly the best in terms of safety outcome for the occupants of smaller vehicles. On the left, we have wire rope and now superseded wire rope product. Now that we've transitioned to mesh, there is a new range of products accepted to the mesh test level. They're a higher barrier than the previous ones because they need to contain some bigger vehicles. On the right-hand side, we have a flexible W-beam, which is, I guess, the younger cousin of the wire rope. Both of these barriers fall into the flexible barrier category. They work primarily through tension developed in the system. The posts do provide some lateral support, but it's important that they're adequately anchored at either end. In the case of the flexible guard fence products, is a sort of a ribbon effect developed in the system when it's impacted, as opposed to the old Type B guard fence, which operated primarily through the lateral support offered by the posts.
Jamie, sorry to jump in there. There was a question in here around the Type B or G4, and sorry, I should clarify to everybody why we sometimes say Type B guardrail, and sometimes we call it G4. Victoria calls it Type B everybody else calls it, oh no, hang on. Does everybody else call it G4? Yeah, pretty much.
G4 is a much more common product around Australia. They're actually slightly different, but they are the public domain guard fence systems used across the country. So G4 is sort of the equivalent in a lot of other states.
Yeah,
to our type B guard fence.
Slightly different rail length, but apart from that, they operate the same.
Right.
The question though is really around, well, okay, we've identified now that these only meet test level 2. So why aren't we upgrading these and ripping them out as we go through jobs and replacing them with a barrier system that we know is a higher containment level and going to operate better? What's our justification for that?
Good question. Look, the test level, the MASH testing regime is, it involves some pretty severe crash conditions, conditions that are probably not common on the network. They're a worst case scenario. So we do know that these barriers will contain a lot of vehicles a lot of the time in real world situations. So it's probably not economical a lot of the time to go around and upgrade them. We do upgrade them on occasion if we're treating a particular length of road and we go through it and we find that there are existing type B guard fences. We might be installing continuous barriers. And the existing barriers have probably been located at the highest risk location. So it probably is worthwhile to upgrade those to currently accepted products. There's not a mass sort of program to upgrade these barriers. They do perform well in a lot of situations.
I think that point there is a really, really good one, Jamie. For those continuous barrier jobs, if you were to just simply infill with the best barrier where there wasn't any barrier and leave the old barrier that's been there for 20 years, as Jamie said, the odds on are that whoever decided to put barrier in there in the first place had a good, justification, and they were targeting an area of particularly high risk. And so what we will inevitably be left with in these continuous barrier jobs, if you take that philosophy, is that the areas of highest risk have the worst barriers. And the areas of lower risk, not to say like they've still got risk, but have the best barriers. So you do need to factor that into those continuous jobs. And then there is a general sort of rule that if a barrier is struck to a point where you're going to replace it or a significant part of it, is you step it up to the current system. But if a type B gets a small hit and it's just getting a little bit of a patch, you don't tend to replace the whole system out of the maintenance bucket. So it's one for a continued bit of thinking. Another question's come in. Sorry to derail you here, Jamie. As traffic increases, is it likely that we will have to go back and upgrade the existing barriers as products become superseded? I suppose we've sort of covered that, haven't we, there? It'll be a sort of continuing decision.
Yeah, there's probably a lot in that question. The vehicle fleet is changing over time, no doubt, and we will see newer products into the market. So there may come a time where there are better things available and we're catering to different vehicles. When that's the case, there'll be newer vehicle technologies. Perhaps barriers won't be as critical a component of the safe system approach as they are now.
Yeah, but I think the other thing to remember, and you sort of framed it quite well, I think there, Jamie, is so as we maybe take an NCH up a 350 end terminal or something like that, so an X350 or the like, and now we know that is not a product that's accepted, that's into legacy status. It's not like that is unsafe. It's just that we have something a bit safer, if that makes sense. So people will sometimes see that as that doesn't conform, but you go, Okay, it's just that we know we can do it. We can do a bit better than that particular product because new technologies come along, but it's not dangerous. As opposed to some things out there that actually are presenting risk. But good question, good discussion. Let's keep moving on, Jamie, and we may have some more of that type of discussion a bit later.
So there's the two flexible systems, wire rope and the flexible W-beam. Both sit in that same category. Wire ropes are just that little bit more forgiving. They have a slightly higher or better crash reduction factor. And for that reason, if space is not an issue, and there are no other reasons against wire rope, it is slightly preferable from a safety point of view. These barriers do deflect by quite a bit, and especially the wire ropes, which make it difficult to apply in some situations. Because of that deflection, they are the most forgiving on vehicle occupants. But the barrier also does sustain quite a bit of damage when impacted. Typical lengths of damage, might be something like 60 or 80 metres. In the case of wire rope, the posts may be knocked down, the ropes dislodged, even dragging on the ground. So the barrier in that vicinity, at least, is useless potentially until it's repaired. Wire ropes are difficult to apply in constrained situations, not so much flexible W-beams, due to curvature horizontally and vertically, and the minimum length requirements for those systems. So that was just a little bit of a recap of the different barrier systems available, and you really do, as a designer, need to be aware of the ins and outs and the pros and cons of the different barrier systems. A little bit of philosophy. Ostroad says that a barrier should only be installed when that barrier reduces the risk associated with the roadside. There has been quite a shift in thinking there. Previously, barriers were treated as a hazard in their own right. It's now generally accepted that a barrier will reduce the roadside risk at a location. We do need to be mindful of some design things, our choices of product to ensure that we're not introducing risks. AASHTO talks about lowest whole of life cost, and that is an increasing consideration with the rollout of continuous barriers. And pieces of work have been done to compare flexible W-beam and wire rope, for instance, and maintenance costs for wire rope are typically higher. So for that reason, it is sometimes not preferred. But from a safety point of view, wire rope is the best. The flexible W-beams are only marginally behind, so we should be using one of those flexible systems wherever possible.
Jamie, just on wire ropes, quick question came in there around how do you tell if a wire is damaged after an impact, and would it usually need to be replaced, or do you know how that is undertaken?
I believe it's just a visual inspection, and if there's a noticeable kink or fraying of the cable, then it ought to be replaced. It's usually the case that they're not, but sometimes they are.
So we do have a document, maintenance of flexible barrier systems, maintenance inspection of flexible barrier systems, which we can provide. It's a Victorian government internal document we produced for the government. We do have permission to give that out to others if needed, and certainly a lot of you are government. So let us know if you're playing in that space. If day 2 and 3 of the course, when we do them in person, we give out a copy of that anyway, which has a bit more detail in that. One thing and Evan mentioned it, and it's always sort of surprised me the first time I was sort of told it and then shown some different parts of it, is the incredible strength of those wires, and the fact that really it's almost only one of the wires is needed to contain the vehicle. The others are the reason that there are sort of 4 is to just try and ensure one grabs the vehicle as it goes off. It's not there for that you need 4 of them for the strength of the system. It's more just to try and grab. So yeah, like that's why I think if one wasn't performing, it's not like the whole system's stuff. It's just going to be potentially a little less effective. Thanks.
Thanks, Ken. So really the message is know the products available to you, their pros and cons. Speed is critical in determining the need for a battery in the first place. And if you identify that you do need one, narrowing down the choice of products, you need to ensure that you are using a product and an end-terminal treatment that is appropriate to the speed. The consequences of barrier penetration may well influence your choice of barrier system. If you're purely concerned about a single vehicle run-off road crash, you might be inclined to go with a lower containment level than if you have a school or a piece of critical infrastructure or a bridge or the like, where we must at all costs prevent a vehicle, and particularly a heavy vehicle, from penetrating the barrier and going on to cause an even greater issue. So now I'd like to step through a few of those key considerations. We've decided that we need to install some barriers. What are the things that you need to think about to come up with a design solution? It is critical. I can't stress enough how important it is to get out on the ground and assess the site. I've seen too many times people trying to design barrier treatments, even at a concept level, using Google. And it's amazing how wrong people can get it. Assumptions are made incorrectly that mean that a feasible barrier solution is very different from sort of the ideal solution that someone might assume without visiting the site. So get out there, assess the hazards that are present, understand their locations relative to the road. It's important to understand where is the first and the last hazard along a length that you are looking to protect, which of those is closest to the road, how near to the edge line is it. That will influence our barrier offset and deflection requirements. Know your cross section. Take measurements of shoulders, verges, know where the batter hinge point particularly is in relation to the edge of the road. There may be a need for widening to achieve the barrier offset that you want. Keep your eyes peeled for other constraints. It might be underground services. There might be signs and poles and things that perhaps aren't constraints but need to be relocated. Determine the containment level required. I'm not sure if Evan spoke about this the other day, but there is a process in the DOT RDNs around selecting a containment level for a route. And it's often the case that you sort of select a base containment level. That might be test level 3 for a particular route. And you then beef that up at certain high-risk locations along that route. So if you have a containment level in mind, you can select a barrier system, or at least have a short list of barrier systems. And often this is an iterative process. You might have wire rope in mind because you think it's the safest, but you find that for your particular site, there just isn't the space available. So you need to sort of step down the list to get a feasible solution. Design the barrier. Think about the location in relation to the traffic lane. So barrier offset, the shoulder width, the hinge point, whether there's curb or not, all come into play. And we'll talk through those things in a bit of detail shortly. Think about how close the barrier will be to the hazards. And if that is a point hazard, a vertical hazard, we need to be thinking about working width, the space that the barrier requires to work to its sort of full capability. And that does take into account a roll allowance for a heavy vehicle. That allowance is particularly small at a test level 3 barrier because we're only talking about 2.2 tonne vehicles rather than bigger trucks. Think about batter slopes. Are our batters steep enough that we can't install a barrier on it? Are they steep enough that they constitute a hazard in their own right? Are run-out areas available? Does that influence where we start our barriers? Do we need to do some localised earthworks near the start of a barrier to achieve a run-out area? And again, I think Evan touched on that the other day, but we'll talk about that a bit more shortly. Think about terminals and transitions. Where are they to be located? Choice of product. If you have another barrier system that you want to transition to, how are you going to do that? Are you going to create a direct transition? You're going to overlap? So we'll talk through some of these things in a bit more detail now. But before we do that, I think it's important to differentiate between two key design scenarios, those being new roadworks projects and retrofit projects. So here we have an example of a major roadworks project where we have survey information, we have a set of design drawings, and really the barriers just need to fit in with those. And barriers will typically appear on an alignment plan, as you can see there, with pretty minimal information shown. That's because we have a 3D model set up, we have other designs drawn to certain cross sections, so it's evident from the design package where the barrier is to be located. So here we've got start and end points nominated for the barrier, points of need, the barrier type, and terminal locations, and that's about it. It's not a very transparent design. You can't tell from that any information about assumptions around deflection or hazard locations or anything like that. So from that point of view, the designer would need to have documented all of those things. As opposed to a retrofit situation, a run-off road project, as we used to call them, where a road may be being treated due to a high run-off road crash history, and we're seeking to install some barriers at high-risk locations. This is an example of a design plan for such a project. It does use a convention that Vic Roads has used in the past, and don't worry too much about the detail, but you can see there in the yellow text various details relating to the barrier's offset, its deflection, although that's not evident unless you're familiar with the convention, but trust me, it does. So the barrier type is nominated. Some of the design thinking is captured on these plans, and there ought to also be perhaps a spreadsheet or another record capturing even more of that design thinking. That's an example of a retrofit project on perhaps a minor road. Here's a barrier retrofit project on a divided freeway. It's the Hume Freeway, where barriers were retrofitted continuously, as you can see there. So in these situations, really, we're not particularly concerned about barrier lengths. Key considerations are containment level, barrier offset, and beyond that, we really need to be thinking about locations for maintenance access. Where do we break barriers? In the top of that drawing, you can see some similar information that was presented on the previous plan around barrier type, offset, length, and so on. When it comes to barrier length, we use this term length of need. That's basically how long the barrier needs to be to shield the hazard that it's intended to shield. So how far in advance of that barrier of that hazard does the barrier need to start? Our length of need is not measured from the very start of the barrier. It's measured from the barrier's point of need or point of redirection. So that's the point at which the barrier becomes effective in capturing and redirecting an errant vehicle. So it's some meters from the start of the barrier, depending on the system. In the case of a wire rope, it's 10 or 12 meters. In the case of a guard fence, it's perhaps about 4 or 5 from the start of the system. To determine our length of need, there's a few critical pieces of information we need. The first of those being the width that we're seeking to protect. So that's the width from the edge of our traffic lane to the back of the hazard. So that width or area of roadside that we want to prevent an errant vehicle from entering. How near to the road, our barrier offset, is another key consideration. The nearer to the hazard that the barrier is, the shorter it needs to be to prevent the vehicle from reaching that hazard. Speed is a factor, whether or not the barrier is flared. Flaring a barrier helps. If we can kink the barrier away from the road, we cut off that run out line sooner and can provide a shorter barrier. Or if we're in a really constrained location where we can't get the length of need that we would like, flaring helps us maximise the effectiveness of the barrier. Now, I'll just point out with regards to the run out line, in Victoria, we use what's called the run out length method. There is no magic angle that we assume that an errant vehicle will depart the road at. Other states do use what's called the angle of departure method, which assumes certain run out angles and different angles at different speeds for design purposes. We instead use the run out length method, which is more about creating a corridor for deceleration. We assume that a vehicle that travels in behind the barrier, just misses the terminal, will have enough distance to decelerate to a stop or at least wash off enough speed prior to reaching the hazard to avoid a serious event. So it's the run out length method in Victoria. And you can refer to a couple of guideline drawings to determine the length that you need for a particular situation. Now, for any given barrier, there are a number of components that combine to make up its total length. We have what's referred to here as an adjacent length of need. So that's the length of need for a vehicle travelling from left to right. So if you can see my mouse there, we're providing an adjacent length of need to shield the hazard from this errant vehicle. If we've got a two-way road, we also want to shield that hazard from traffic travelling in the opposite direction. So we provide this opposing length of need for the errant vehicle travelling from right to left. The hazard itself has a certain length. So if we combine all of those, we end up with our total length of need. Now, just to confuse things, that is not the total length of our barrier. In addition to the total length of need, we also have a gating portion of our barriers at either end. So this point here, again, is our point of redirection. In advance of that, we have what we refer to as the gating part of the terminal. It's intended to open up like a gate and allow an errant vehicle to pass through. And that does vary with product. There is one of the guideline drawings that I'd referenced. This is the drawing, despite what the title block says down here, it's not line A, it's the line B barrier alignment. So in Victoria, we talk about line A and line B barriers. Line B is this one, which is parallel to the roadway and located close to the roadway. So the assumption is that we can't, there might be a batter that is not of a suitable grade for our barrier to be installed on. So we locate the barrier basically at the edge of shoulder or on the verge, and it's relatively close to the roadway. Line A, on the other hand, is a flared barrier treatment, and we typically locate those closer to the hazard. That's not a practice that we use much these days. It's typically line B.
Jamie, oh, sorry, go finish that, and then I'll ask you a question.
I was just going to say, all of the numbers in the tables that you can see there are our run-out lengths, our lengths of need. So I don't expect you to be able to read all of the numbers, but if you know the protected width that you're looking to shield, you have a barrier offset in mind, and you know the speed environment that you're dealing with, you can look to this table to work out how long your barrier needs to extend in advance of the hazard to adequately shield it.
Yeah, thanks, Jamie. And I suppose the real takeaway out of some of this is that there is a way to calculate exactly how long a barrier should be in its different design configurations. So people aren't just guessing it. Oh, that looks about right. There's an actual sort of science to this and a documented way of doing it, some reference tables and some formulas and some calculations. So you make sure you go through that process. And again, and when we go into more detail in the next few days, in the 2 days in person, you do these calculations, you go through that exercise. The question that had come in was around offset, barrier and maintenance, ability to maintain the roadside, mow the grass, do different maintenance activities. Any comments on that, David?
Yeah, great question. We'll talk a fair bit more about offset shortly, but a choice of offset really is a balancing act. You ought to be providing wherever you can a desirable offset of 3 or 4 meters or more to provide for vehicles to pull over, maintenance activities, all of those things. Sometimes it's not the case that we can, or in order to do that, we might need to perform some earthworks to get that sort of offset. But maintenance really is an important consideration. We need to think about what effect installing a barrier will have on maintenance operations, other opportunities for maintenance crews and emergency vehicles and so on to get in behind barriers where they need to, or will they actually be stranded on the road and perhaps needing to pull over on a shoulder that's not wide enough for them to do so safely.
Good, thank you. Yeah, keep questions coming in. Hang on. We've just got Debbie who wants to say something, and I've just given you the ability to unmute yourself there, Debbie.
Sure. It's just that there's some major problems with a lot of our projects in that they want the area behind it to be quite wide. They want it 2 meters, and the designers say no, or they want it really short at 0.6. And then there's talk of concrete going in these areas to stop the maintenance. It's just that the maintenance people, if they have to mow those areas, they have to close traffic lanes because it's dangerous. So that's where a whole lot of problems are, is that we're making safe for the road users, but we're making it dangerous for people maintain these strips, and especially in 80k sections of Melbourne that have big medians.
So yeah, I think it's a challenge, and there's wider sort of challenges associated with that. We're certainly doing a fair bit of work with New South Wales on their central barrier systems in flush medians and outer containment barriers, and you sort of have these challenges which are somewhat similar in nature, where to fix a pothole or something like that, they basically have to close the road down because there's not enough space to get vehicles around the crew and the like. And to me, there's this sort of challenge we've got to absolutely consider this all the way through the design, and we've got to get better at that. We've got to involve the maintenance crews more as we're designing and work with the practices. Well,
we're trying to, but the designs come back saying, no, you can't do that. They just blatantly say no. So that's what we're finding, is that they want it 2 metered. They want it back 2 meters so they can drive their mowers quite safely down that strip without being on the road and do it quickly. But if you make it shorter than 2 meters for them, it's dangerous. They've got to get whippersnippers in, or they've got to weed kill it. Yeah. And they've got to be a lot more time, which also wastes a lot more money. That's the other issue. And they actually say concrete is the next thing. But then I've heard from other people that that's actually a design problem. You can't put them in concrete because which you
So
guys are obviously experts at.
So concrete, when you say concrete, you meaning like a concrete
maintenance strip of concrete. Yes. But that's really expensive and no one wants to spend money on that. But weeds go through concrete too. You've got to maintain it eventually.
Yeah. Well,
I need to come up with some solutions. Make it safe for everybody, that's all.
Yeah. I mean, that's the objective, absolutely. And we used to use concrete maintenance strips. It was an actual requirement. You couldn't put barrier in without the concrete maintenance strip, and then that sort of went away. I don't think we have magic answers in this. I think the consideration, we need to continue to work and try to be flexible with the designs. But I do sort of often talk about the fact that, well, this one was more in some of these New South Wales cases where the maintenance teams basically were flat out saying, you cannot put this barrier system in. We refuse to let this happen. And to me, it was, we have people leaving the road, leaving their lane, being killed and seriously injured, members of the community. We have to address that, right? We have the maintenance crews and our maintenance operations, which we have much more ability to alter our processes, our procedures, our machinery. So it becomes the one where I think, we should do everything we can to try to make it so within our current operations of maintenance, we're able to continue doing that. But I think if we can't, the idea of not putting a barrier system in is not the answer to me. It's changing our maintenance practices to adapt to the way we do this. But
I think what's interesting is it's not they don't want to put them in; they just want to make it safe for their maintenance crews.
Absolutely, and as we all do. So we need to continue to work on it. So sorry, not too
all good. Thank you.
Many magic answers for you there. Maybe Jamie's got a magic answer, do you?
Unfortunately not.
Okay. Well, let's keep going on, and we'll discuss a few other issues a little bit later on. Thanks, Debbie.
I'd mentioned that in Victoria we use the run-out length method for determining our lengths of barriers. And you can see here a situation where a vehicle has departed the road and continued along the roadside and ended up in the creek. There is a barrier up here in the distance, which I suppose has been designed to shield the worst part of the drop-off there, the overpass, but certainly hasn't extended far enough to shield the entirety of the hazard, being the waterway and the poles and everything else. So if we were designing the barrier in accordance with the run-out length method, it would have extended much further towards us. And it is often the case that we find these token lengths of barriers, especially at structures. You can see here the barrier basically, the length of the barrier is basically the same as the length of the structure. And we've got this 10-metre terminal tacked on the other side. Now, this is a gating terminal. It's ineffective in capturing an errant vehicle. And obviously a vehicle has left the road and struck the tree here. Now, if we were designing that barrier based on the run-out length method to shield an area of roadside, and the question of how much of that roadside you shield is a tricky one to answer when you're dealing with something like a waterway that extends continuously from the road. But if we were looking to shield that tree in the least, we would find that our barrier extended a long way up the road, perhaps 100 metres or something like that. Other states do use the angle of departure method. This is a snip from the Austroads guide, which gives those magic angles, different ones for different speed environments. So that might be one for you, Paul. Barrier offset is perhaps the key consideration to make when you're installing a barrier. How near to the road can we install the barrier, or where do we want to locate the barrier laterally? There is guidance around this, both in the Austroads guide, fairly vague, and more detailed guidance is provided in the DOT information. 4 metres is the desirable minimum offset for a barrier. Now that provides space for an errant vehicle to recover and get back on into the traffic lane without striking the barrier necessarily. It provides room for a vehicle to stop in an emergency situation when they have to. Perhaps a truck's blown a tyre, they need to pull over and change the tyre. So there's enough room for the vehicle, for the door to open, and for someone to do what they need to do at the roadside. 3 metres is our minimum, or our sort of, it's our minimum offset. It provides just enough room for that vehicle to pull over at the roadside. It's an offset that we've used commonly in the past. The strong preference these days is to go with a 4 metre offset, and even greater, up to about 6 metres on some major roads where it suits us to. That might be because there's a longitudinal service sort of running along the edge of the shoulder and we can't get something at 4 metres. We can push that barrier back to up to about 6 metres if we've got the formation that allows us to do that. If we go beyond about 6 metres, we really are opening up that opportunity for the vehicle to increase its angle of departure and strike the barrier at a more severe angle, resulting in a higher severity crash. Offsets less than 3 metres are considered absolute minimum offsets, and they require approval or an exemption from DOT, and there's a process to go through. There are plenty of barriers out on the network that are at offsets less than 3 metres. There are some important design considerations to make if you are looking at installing a barrier at less than 3 metres. The length of barrier is very important. If your length of barrier is very short and you're not really compromising the ability for someone to pull over at the roadside, there are opportunities before and after, then you can go below 3 metres. If you're flaring your approach terminal away from the road so that it's not particularly close, we're not introducing effects where drivers sort of shy away from the barrier and increasing the likelihood of nuisance impacts, then we can get away with offsets less than 3 metres. It's particularly in those continuous installations that we really do need those 4 metres and 3 metres at a pinch offsets. Guidance talks about bare minimum offsets of 1 metre and even 0.6 of a metre. And they're the sorts of offsets that we sometimes see at structures in particular. But generally speaking, the approach barriers to those structures are at greater offsets and they flare away such that the starts of the barriers are at good offsets from the roadway. So it really is a balancing act. We want to get the barriers a distance from the edge of the road, but not so far that there's the opportunity for greater impact angles, and even the potential for sort of rollovers before reaching the barrier. So it's really as easy as saying, yep, I'm going to put in a 4 metre offset. There are lots of things that come into play. If there's curb present, that affects things. Often the formation just doesn't allow it. So know where your batter hinge point is, so the location at which the verge ends and the batter starts. If there are table drains or other changes in direction, that will influence the scope of where we can locate a barrier. You may need to do earthworks to get an offset that is desirable. Shyline offsets. Austroads does provide guidance on minimum offsets, which are referred to as shyline offsets. Research shows that objects located particularly close to the road and within certain distances sort of surprise drivers and cause them to shy away from those objects. So to avoid those effects, we keep our barriers outside shyline offsets. We're talking about something like 2.4 metres in a high-speed 100k environment, and those offsets reduce with speed. So you might consider shyline offsets as an absolute minimum offset. And I always think that the offsets, the shyline offsets, sort of, correlate fairly well with the amount of space that we typically provide for cyclists on a shoulder. So if you're achieving a shyline offset, you're also providing a typical sort of cycle lane width if cyclists are present. Barriers can be flared away from the road and often should be where we're dealing with some minimum offsets. Where we're doing that, we need to be mindful of the rate at which we're flaring. There are prescribed maximum flare rates that we should use to avoid the potential for motorists to strike those flared sections of barriers at too high an angle.
And is this at all speeds, Jamie, or?
Yes, there is no distinction made for speed, although that, obviously the risk associated with not achieving these offsets increases with speed. It really does depend on your road environment. If you're in a built-up environment, that's perhaps 70 or 80 kilometres per hour, and you've got frequent side roads and opportunities for people to get off the road, and you've got curb, your barrier might be at the back of curb. If you've got a multi-lane carriageway, there's greater opportunity for vehicles to bypass broken down vehicles. So there's lots of things that come into play, and there are lots of situations where we don't achieve these offsets. It's particularly those high-speed continuous barrier situations where these offsets really are important. This is Sydney Road in Melbourne, and you can see there a wire rope at back of curb. So basically 0 offset or, a few hundred mil. This barrier is frequently struck. It's a real maintenance burden for a couple of reasons. It's so close to the road. And also the choice of barrier system is probably not the best one here. When that barrier is struck, as you can see there, a number of posts are knocked down, the ropes slacken. A subsequent impact at this location, we can't be sure if an errant vehicle would be contained. If that was a guard fence, and we might get away with a type B guard fence here due to the speeds, very little damage would be incurred, and the likelihood is that you wouldn't need to get out there and do any maintenance on that barrier.
And do you know what the speed limit is here? It's 70, or is it?
I think it is.
Yeah. It was 70. It's up. Well, it's in Faulkner. You can see from Faulkner discounts in the background, just on the approach up to the M80 there, the ring road. I think it is still 70. Although Damien thinks it might be 60, but I think it's 70.
This photo raises another important point. It's a question that's often asked: do these offsets apply to barriers on both sides of a one-way carriageway? The answer, I guess, the short answer is yes. Although they're particularly important on the left-hand side of a carriageway. If we're talking about a divided highway with multiple lanes in each direction, it's critical to get these sort of offsets on the left-hand side. We should be providing them on the right-hand side where possible, and especially if there are 3 or more lanes in a single direction. If there are only 2 lanes, what usually happens is that the motorists will pull over to the left. But if there are 3 or more, there's an increased likelihood that a motorist in one of the right-hand lanes will choose to pull over to the right, in which case we should provide an offset that will allow them to do that.
Sorry, I have to qualify something, which is a very good point. If Jamie flicks back to a slide that has a Wally, it's still only one Wally. Very good point that came up there. A couple of other things there. I just did double check that it is 70 kilometres an hour for that Sydney Road example. That section is still 70. Do these offsets apply on slip lanes too? That's an interesting question.
Good question. Look, the distinction is not made in the guidance really as to where they apply, but in that sort of situation, it would be, it'd be ridiculous really to look. It depends on your slip lane, your situation. If it's an urban slip lane and it's not a location where you'd expect someone to pull over, in any case, then it would typically not be necessary.
Thank you. Tim's got a question around people using wide offset areas as a running lane, a traffic lane or the like, and make some commentary around some of the challenges with wide lanes and people sort of using the road to take, or wide, sometimes shoulders and those sorts of things. Any commentary around that, Jamie?
Yeah, look, it does happen on occasion in congested conditions, especially urban freeways, approaching exits and this type of thing. People will get on that left-hand shoulder and bypass queued traffic. And where you've got an offset of, 3-4 metres, it can appear as a traffic lane, and certainly provides that opportunity. I would not advise reducing the offset, to less than 3 metres, say, to deter that behaviour. Look, I don't know what the answer is there. It does have its safety risks associated with it, and it's certainly not desirable.
Yeah, I tend to agree with you there, though. I don't think the barrier offset is the real thing there. It's as much the presence of a large shoulder, same thing would happen, and the like. And we can think about minimizing that through other means, be it some staggered paintings, some flexible bollards if it's a real problem area where they're ducking around. But I don't think the alteration of barrier offset is really, in the majority of cases, going to be your go-to in reducing that.
A couple of pictures here to really demonstrate how the approach to barrier design has shifted in perhaps the last 10 years. This is a barrier retrofit design plan that's probably about 10 years old. It's the Western Highway, west of Melbourne. And it was decided to shield barriers within a certain clear zone. And from memory, I think a 12-metre clear zone was adopted at the time for this project. So we're installing isolated barriers around identified hazards within the clear zone. So things, hazards at 11.5 metres were shielded, those at 12.5 probably weren't. The approach was to locate barriers as close to those hazards as possible, subject to the slopes in front. And that did result in a whole range of offsets as you drove along the road. You may not be able to see the numbers, but we can see this barrier on the median. So we had a 6.1 metre offset, and that was dictated by deflection requirements to the closest hazard to the barrier. This one down here was at a 5.5 metre offset. Here, somehow we got a 3 metre offset. So the barriers really did sort of step in and out. The intention of that approach was to provide as great a recovery area as possible, to minimise barrier length, and cost was probably the primary consideration. Having those sort of 5 and 6 metre offsets and in those grass medians does open up the possibility for rollovers, for higher impact angle crashes with those barriers. the same section of road has since been fitted with continuous barriers, and marrying up this old approach with the new, where we were looking to provide barriers at those 3 and 4 metre offsets, I'm sure created a lot of headaches. And a lot of these barriers, or some of these barriers at least, were removed. So if we were doing this again, we'd probably have a 4 metre offset on the left, maybe a 3 on the right, consistently along the whole route. I mentioned earlier there are a number of things that can influence our choice of offset, and one of those is the presence of curb. When errant vehicles traverse a curb, it affects their bumper height and trajectory. With that in mind, we want to avoid locating barriers in locations where the bumper height differs from normal. So some guidance in the DOT supplement includes this diagram and chart, and it identifies a number of different zones. Now, there has been a bit of a change in thinking. Rod Troutbeck undertook some research recently, and based on that, some clarifications have been made. We now prefer to locate barriers in what are called zones 1 and 2. Zone 1 being at the back of curb, and zone 2 being a significant distance back from the curb. So far enough back that the vehicle has bounced up and down after crossing the curb and has returned to around its usual height. So those distances are something like 4 metres or greater. Certainly in high speed environments they are, and a bit closer in lower speed environments. In the past, we've also on occasion looked to install barriers in a zone 3, which is now sort of less preferred, I suppose. It's referred to as tolerable there. Zone 3, there are 2 elements to zone 3, but the old zone 3, I suppose, was a distance of about 1.5 metres, roughly, back from the curb. So the vehicle had sort of bounced up and was coming back down. And if we had underground services perhaps behind the curb that meant we couldn't install a barrier at back of curb, we'd look to that next zone. It's very rare where we've got curb that we can provide a barrier in zone 2. If we've got curb, we're probably either in a built-up environment, and we just don't have that luxury because of everything else in the nature strip. Or if we're in a rural environment, we're probably in a cut if we've got a curb. So there's a limited verge width to play with. So the preference is to put barriers in that zone 1 at the back of curb or as close to the back of curb as possible to take out the effects on the bumper height of the curb.
So, a couple of questions. Do we need to consider the verge of a road as part of a hazard, as a poorly maintained shoulder can contribute to an accident or crash? My answer would be no.
I'll just get my head around that.
Sorry, Jamie, you're still there.
Yep.
No, sorry. The answer to that is really no. I mean, a poor maintenance of a shoulder is not really considered a hazard in the sense of a point source hazard that you'd be using a barrier to protect. I mean, I think that's more of a sort of maintenance challenge. You'd consider the bouncing around of it a bit your barrier there, but not the same way you would a curve in that vaulting scenario. But if there are pedestrians present, is zone 1 preferred? Zone 1's preferred all the time, isn't it?
That's right. If there are pedestrians present and we had a footpath, probably zone 1's all the more important. We generally avoid the situation where we've got a barrier located behind a footpath, which might mean that pedestrians are sort of located between the barrier and the road, and an errant vehicle is sort of directed along the footpath.
Yes, and so jumping around the questions here a little bit. What's the length of zone 1? And that actually links in with the next question, which was around table 5.3 and VicRoad supplement to part 6, which actually shows some of those details and has the diagram specifically set for that. So you should refer to 5.3 of Guide to Road Design part 6, and it shows, now I'm going off the top of my head, 200 to 400 or something is the one. I can look that up because we did a Safe System snippet on it yesterday, just recently. And then, so that's that one, but yeah, do use that. And then Debbie's question around, isn't zone 1 in the shy line zone? Well, it would depend where the edge line is, really, wouldn't it, Jamie? So if the running lane was right up to curb, then possibly, but usually there's an edge line somewhere away from the curb.
That's right. If it's a rural environment, you'd have a shoulder. You'd likely have a shoulder that would mean that it was outside the shy line. If you're in a built-up environment, probably shy effects are less because drivers are more alert. The important thing is the location of the terminal as well. So that the parallel section of barrier might be within that shy zone, but if the terminal can be flared away, that can reduce those effects as well.
So an on-road cycle lane adjacent to zone 1 barrier has also been raised a concern. What are the considerations in this case? Now that's a good one. So certainly in the barrier design exercise we would get you to do on day 3, have some of those exact challenges, and there's lots of different ways to consider that and think about it, potentially even put the barrier traffic side to protect cyclists from errant vehicles or moving it around. Any further comments on that, Jamie?
No, not really. Look, it is important we don't compromise that width available for cyclists. The diagram there sort of shows zone 1, or sort of implies that the face of barrier would probably be in line with the face of curb, which is what we try and do for a barrier curb. In practice, where we don't have a barrier curb, if we have a semi-mountable curb, typically our face of barrier would be sort of in line with the back of curb, or perhaps a fraction behind, in which case we wouldn't be compromising that width for cyclists, but it is an important consideration.
And there's also the challenge of driving your post down into subsurface drainage sometimes as well, isn't there, when it's right, right at the back of curb there. So again, practical challenges and considerations. Okay, let's keep moving on.
Next consideration in determining an appropriate barrier offset is where is your hinge point? So know the distance available between the edge line and the hinge point, this guy here. Within that verge, we need to provide an adequate width to support the system, and that does differ with our systems, our different product choices. For guard fence products, it's 0.5 metre minimum. For wire rope systems, it's greater. It's 1 metre minimum, but we also need to be mindful of the deflection of the system, and often we do need to provide more than that 1 metre to ensure that enough of the deflection occurs on that verge, and that an impacting vehicle doesn't disappear over the hinge point. So often what we do is we work backwards from the hinge point. If it's not feasible to undertake earthworks to improve our barrier offset, we will locate our barrier as close to the hinge point as we can. So if we've got perhaps a 3 metre distance between our edge line and hinge point, we need that 0.5 metre minimum to the back of barrier. Then we have an offset in the order of 2.5 metres. And to do better than that, we would need to undertake some formation widening. Where we're getting particularly close to hinge points, we can do things to mitigate the risk of that, such as installing longer posts or reducing our post spacing to stiffen up the system locally. The suppliers can provide some guidance around that. Now, also, this half-metre minimum offset is, I guess, is sort of a one-size-fits-all minimum, a preferred minimum as per DOT guidance. Some products have been crash tested at lesser offsets from the hinge point. And in constrained locations or on sort of, locally within the length of a barrier, it may be permissible to reduce that. Little video which I hope comes through.
It came through well for me.
Great. I'll just play that again. So here you can see a wire rope installed pretty much at the drop-off. And obviously the errant vehicle has been contained and redirected. So what that shows us is that it is okay if a barrier deflects out over a batter. The preferred situation is to contain all of the deflection within that verge, but certainly in a retrofit situation, that's just very rarely happens. And we accept that some of that deflection will happen out over the batter. Allowable batter slopes. There are batter slopes on which we can install barriers, and if our batter slope is 10:1 or flatter, we have no concerns. We can locate our barrier on that slope. An alternative solution is provided in the diagram there that really we've gone away from. So, look, I would strike that out. That alternative solution where we have a barrier beyond the toe of a steeper batter is not something that we do. It doesn't fit with our desirable barrier offset, sort of in the range of 4 metres. The preference would be to locate our barrier nearer to the edge of the carriageway at around that 4 metre offset. Another video coming through. That barrier has obviously failed to contain that vehicle. Why? That view tells the story. That barrier is located just beyond the invert of a table drain. If I play it again, you can see that as the vehicle passes through, what's happening? Sorry, Ken, technical difficulties. Can you hear me?
Yeah, it's still got you. It's just the spinning wheel of death going on there.
Yeah.
On your screen. So you might have to jump out of your presentation, which is okay because I can take over for a little bit. Oh, geez, PowerPoint's restarting. It's all happening down there in Hamilton. If you get that going, I can get started. We did plan our break in half an hour or so, so I might take over. We'll see if there's any questions have come in. How's it going there, Jamie? Should I start on motorcycles or are you back up and running shortly?
I'm nearly there, I think, Ken.
Okay, no worries. I
won't try my luck again with that video. Sharing again.
Yep, gotcha. So was that the video of the car going under the? Yeah, we saw it the first time, so
Yeah,
that came
right.
through nicely.
So the moral of that video was to avoid locating barriers at locations where there is a change in grade. So that might be you don't want to locate a barrier in close proximity to a table drain, a curb, and so on. We want a vehicle to be impacting a barrier on as flat a grade as possible and as close to its normal position as possible. Barrier deflection, I guess, is the other part of the equation when we're thinking about barrier offset. You often have a hazard located at a certain distance from the road that you're looking to shield. The barrier sits somewhere between the edge line and that hazard. We have desirable barrier offsets in mind, but we may well find that if we locate the barrier at that desirable offset, we just don't have adequate space for deflection. That might influence our choice of product. We might need to do things to stiffen up the system. So it really often is a balancing act. So the deflection is that horizontal distance that the barrier will move when struck by an errant vehicle. For rigid barriers, it's next to nothing. For the 3 flexible W-beam products, it's about 1.6 metres for each of those. Now that's under MASH TL3 test conditions, 100 k's per hour. If you're in a constrained situation and you can't afford that, you might want to contact the suppliers to get some information on lesser deflections at lower speeds. Wire rope systems, with the newer MASH products, the minimum deflections have increased to around 2.14 metres. They're all sort of in that ballpark at MASH TL3. One of the wire rope systems is accepted at TL4 as well, but in that case the deflection is significantly greater because we're looking to contain that 10-tonne truck. And they can be as much as 4 metres or even greater. If we're on a curve, on the convex side of a curve, and if we have a particularly long installation, the deflection can increase even further. There's a barrier that clearly doesn't have sufficient space for deflection between it and the pole. The post spacings appear to have been closed up, which is good, but wire rope is probably not the best choice in that situation. A guard fence product with its lesser deflection might have been a smarter choice. Again, another rigid object located within the deflection zone. So the preference obviously would be to remove or relocate the hazard on the right. There isn't any or much scope to adjust the barrier offset in either of those situations. So really it's a case of adopting a system and stiffening it up as much as possible if you are retaining those hazards.
Jamie, just I suppose if you go back onto that wire rope one, and so I've always had a vision on these sort of ones where you're actually potentially increasing the risk of striking that pole to a degree. If an errant vehicle hits that at the flex, it's going to draw a vehicle into the barrier system because the wires will push back on the pole. So I suppose how do you balance up that? Okay, some light hits on the barrier system will stop it, but then heavier hits will actually sort of pocket it and draw a vehicle back into that hazard. Any comments on that?
Yeah, no, I agree with that. There certainly would be a zone where you're probably increasing the likelihood of an errant vehicle being directed into the pole. So I think it comes back to the choice of system. A guard fence would have been a better choice there because of its reduced deflection. It also depends on what else is happening along that stretch of road. what other hazards are present. It might be that there's a whole series of hazards and all of the others are being shielded perfectly well, and this is the odd one out. So the barrier on the whole is doing, serving a good purpose. Yeah, it's a good point.
Thank you.
Another one here where we've got a pole basically touching the rail. Right at the property boundary. It's a power pole that we're not going to relocate. The photo doesn't show it, but there are other hazards upstream of this point. So look, we can probably get a bit bogged down in things not being to standard. The important thing is to do all the things within our power to make a barrier as good as it can be. So stiffening it up in these constrained situations, choice of product to ensure that it will do the best job it can in a constrained location like this. This barrier, it's probably in some sort of low impact angle situations might direct someone around that pole. Minimum length requirements. You may be surprised to learn the minimum lengths that are required for certain barrier products. They are all spelt out in the TCUs and the detail sheets. There was some previous guidance in one of the Vic roads, or a couple of the now superseded road design notes, which suggested that you could get away with some pretty short lengths of barrier, especially for guard fence and type B. That's not so much the case anymore. We really should be providing minimum lengths in accordance with the TCUs. Now, they are basically the crash tested lengths. And they can be quite difficult to achieve. We're talking something like 80 metres for guard fence products and 110 or thereabouts for wire ropes. It's not to say that lengths, shorter lengths than that, the barrier won't work, but I don't think anyone's sort of prepared to put their head on the chopping block and say that they will in the absence of a crash test at those shorter lengths. ASBAP has provided some additional advice in a technical advice that you can see there that gives some practical minimum lengths for W-beam barriers. So you might consider those as absolute minimum lengths. So, 24 metres or thereabouts, 28 metres for WM systems, and for wire ropes, 50 or 60. Now I'd have to, I suspect those exclude terminals. So by the time you add your terminals, you're looking at some 20 or 30 metres in addition to that. In the past and on the network, you do see a lot of guard fence installations at very short lengths, sort of in the order of 30 metres or thereabouts. That goes against current guidance. But it's not to say that a barrier of that length won't provide some safety benefit. There is some critical minimum length, and it varies with each crash situation, how long that length would need to be. But barriers do require a certain minimum length, a certain number of posts, a certain stiffness and structural strength to resist an impacting vehicle, and that increases with its length. That installation, and you commonly do see this around the network, that certainly does not meet minimum length requirements or length of need requirements in any way. This is a stock underpass. You see these type of installations at structures in general. You've got a 5 metre length of guard fence, plus a gating terminal, plus a trailing terminal. no consideration has been made to run out length and shielding the hazard, being the drop-off at the roadside. So that barrier, I'd suggest, ought to be significantly longer either side of that structure, and might end up being something like 60 or 70 or 80 metres. DOT provides some guidance around providing run-out areas at barrier terminals. Now, I think Evan did touch on this the other day, so I'll just talk to it quickly. Run-out areas are those areas near the terminals which are required for a couple of things: to allow the terminal, when struck, to operate freely. So these run-out areas need to be clear of any fixed hazards and have a relatively flat grade. They're also the areas where errant vehicles will typically pass through or end up in when they do strike a barrier terminal. So we want that area to be free of hazards and relatively flat again. They should be clear of any hazards in any case, because if we've designed our barrier appropriately, it would extend far enough to shield any hazards behind. Sometimes providing a run-out area might influence where we do start a barrier. We might decide to extend it a little further to an area that is relatively flat and where we can achieve a nice run-out area.
So, Jamie, the question that's come in is around driveways and trying to put barriers between driveways and the like. You've got, short distances to deal with. How do you deal with that?
Yeah, that's a good question. There are plenty of situations where you just can't get a barrier that is in accordance with minimum length requirements. So then you really need to, think about what the hazards are, what the benefit of installing a barrier within the available width is. I suppose a practical minimum length of barrier would be something like the length of 2 terminals plus some short distance of barrier in between, 5 or 10 metres, say. So that'd be an absolute minimum length that you could physically install. Your speeds come into play. If your speeds are less than 100 k's per hour, the length reduces. Those minimum length requirements are based on MASH TL3, 100 k's per hour, 25-degree impact, and so on. So we do commonly see shorter barriers installed in those constrained locations. It is a design exception, but if there are some significant hazards present, like poles, if the risk is elevated for some reason, if it's on a curve or there's a history of run-off-road crashes or whatever it might be, probably installing that shorter barrier is better than leaving the hazard exposed. Where we are at driveways, we really do need to be careful that you see plenty of times barriers installed and we try and extend them as close to the driveway as possible. Often they're subject to nuisance impacts with turning vehicles. Sometimes we impede sight lines, so we have introduced a safety risk. If we're installing those barriers at a 3 metre or greater offset, we generally don't have a problem with sight distance, but that's a really important consideration at driveways. Moving on to end treatments, any barrier needs to be appropriately terminated with an end treatment, and those end treatments perform 2 functions. They provide a safe crash outcome when struck end-on by a vehicle. The MASH testing regime has a variety of tests at terminals, different angles, different locations of impact, and so on. The other function they perform is to provide anchorage to the system. So wire ropes operate through tension developed in the cables. It's important to have that, that anchor. And similarly, the flexible W-beams as well largely operate through tension developed in the rail. There is one for each proprietary product, flexible W-beam or wire rope, you need to use the corresponding end treatment. So that's another change that's happened in recent years, where there was a bit greater opportunity to mix and match, especially with guard fence. It may have been mentioned before, grate is the generic term that we use in Victoria to describe this type of terminal. Perhaps you can give a prize, Ken, for the first person to tell us what grate stands for.
All right. Yes. Any prize for any of the letters? No. Look at them all. Give them a second there.
So I'm not talking about this specific product type.
I think Joseph's got
Pretty
it there.
close.
Oh, yeah. Get well. Yes. I'm going to give the prize to him. Gating. Yeah.
Gating redirective energy absorbing terminal.
We'll give it to Paul and Joseph there. Yeah,
So I think
yeah, that's all. That was really a Victorian thing, isn't it?
it is. So that's the term that we use in Victoria to describe terminals that are tested to withstand end-on impacts. And we should install a grate at any location where it is feasible that the barrier could be struck end-on. In the past, we may not have provided these on the departure end terminals on two-way roads. And that was often based on the thinking that, the departure end terminal was further from the approaching traffic stream and perhaps outside the clear zone. So that was the excuse, but that's not how we go about it anymore. And that's what they do when they're impacted. These treatments are about 16 metres long or thereabouts. They bring the vehicle to a controlled stop over that distance. Where we have two different barrier types, we need to transition them somehow. It's sometimes the case when you're designing that you have existing barriers on site that you need to work around. In those cases, you might transition directly to those if the barrier types that you're dealing with are compatible. You may provide an overlap transition such as this one. Now, I'll point out that the vehicle you can see there is facing the wrong way. This is a one-way carriageway where traffic will travel towards us. This overlap is not ideal. You can see a breakaway cable terminal with timber posts here. So its point of redirection would be about here at the bottom of screen. The wire rope terminal's point of redirection is probably about the second post there. So there's a small opportunity through here for an errant vehicle that strikes the barrier to pass through into the roadside. We desirably would overlap those points of needs to remove that opportunity altogether. Another overlap where the points of need, I reckon they're overlapped. Very limited width between the systems. Where we are overlapping like this, the distance between the two systems should at a minimum be the expected dynamic deflection of the upstream system, in this case, the wire rope. So that's, something like, for these products, 2 metres, something like that. It's a bit difficult to appreciate here, but there's quite a steep batter. So I think was the reasoning here. They were quite constrained. It would have meant some significant earthworks to get a greater offset. But it would have been nice to see a greater separation between those two systems. I think that's the reason why the type of guard fence terminal, why that type of terminal has been chosen. It's probably been accepted that they haven't provided the separation they need, so they've provided a grate. Whereas if that terminal was set back further, we might have gotten away with a trailing terminal, and the assumption would have been that an errant vehicle would never have reached that terminal. Another typical type of transition occurs at structures or any location where we're transitioning to a concrete barrier. We provide a semi-rigid barrier connecting to a rigid barrier. And where we do that, we need to provide a gradual increase in stiffness as we reach this point here to avoid the possibility of a vehicle snagging at that point. So you can see a reduction in post spacings here as we approach the concrete. That rail is probably also double nested to further increase its stiffness. So a few parting comments on design issues. It really is important to be aware of the limitations, the ins and outs of the different barrier systems. You may well have one in mind, but once you understand the constraints of the site, you might have to revisit your choice. Be aware of those minimum length requirements and try to provide those wherever you can. There are constrained locations where it's not possible. If you're not constrained, it may be the case that your minimum length requirement exceeds your calculated length of need, in which case you might extend your barrier further. Short breaks in barriers should be avoided wherever possible for a couple of reasons. Terminals are the most hazardous part of a barrier system, so providing short breaks in barrier means more terminals, greater potential for injury crashes. You may well find that it's a cheaper solution to join up successive lengths of barrier. Terminals are the most expensive part of a barrier system, so by providing an additional length of barrier, but reducing your number of terminals might actually be a cheaper solution. Of course, where you're doing that, you need to be mindful of access and maintenance requirements. You should be flaring barriers where you can. Now, this is particularly important where your offset isn't what it perhaps should be. If your barrier offset is 3 or 4 metres, there's generally not a need to flare it away further from the road. And when I'm talking about flaring, I'm talking about flaring away the approach end of the barrier. But if we are within that, say 3 metre offset, flaring away from the road at the terminal can open up sight lines if we're near a driveway or a side road, can reduce the likelihood of nuisance impacts at the terminal, can reduce shy effects, can provide better shielding of hazards located near the start of that terminal. So if we're in a constrained location near a driveway or something, we've got a pole or a drop-off near that driveway, flaring the barrier around that hazard can maximise the effectiveness of the barrier. Do provide run-out areas wherever you can, and really be mindful of other assets at the roadside. Existing signs and lighting may need to be removed, reinstated. If they cannot be, we should be mindful of deflection requirements if those assets are not frangible, or even if they are frangible light poles. It's common practice to reduce post spacing and stiffen up barriers to avoid that, I guess, unknown interaction if a barrier was to deflect into one of those assets. There are a whole heap of other considerations we need to make when it comes to design. We've touched on some of those already. Happy to take any questions, perhaps after our break, Ken, or in our session later today, where some of these things will come up again.
Yeah, thanks, Jamie. I don't have any specific questions at this stage. Damien was asking a question around whether that's an exemption requirement for the two barriers that were quite close together, the X350 and the end of the wire rope system there. I would say no.
Look, probably, strictly speaking, probably yes. There is some guidance around that. So it's, yeah, you're deviating from that guidance if you're not achieving, you know, that dynamic deflection space. Yeah.
So, but because it's a product designed to be hit at that speed, so it's like the one where you've got slip-based poles in the deflection zone of a barrier system. That's a real, you know, you go, it's a slip-based pole. We don't know how it performs, so we don't want it there, but it's kind of, yeah, who knows?
If you're providing that type of terminal that we saw in the picture, yeah, it's a grey area. Yeah.
Very good. So good question there, David.
That's it from me, Ken. Apologies, I think I've gone a little over time.
No, that's fine, Jamie. We're going to take a break now and we'll pick up any questions that have come in over the break. So just before 11:15, so we'll go 10:43. We will get started again. If you're in your seat, logged in, ready to go, you're a chance to win a prize. You do not have to do anything in this break. So this is genuine break time. Get a coffee, have a stretch, go walk outside, get some fresh air, and we'll get back into it. But if you do think of any questions as you're going, or you have a particular site or something that you want us to talk about in the last little bit, we'll do that. But I'm going to come back and briefly talk to you about motorcyclists after the break. So enjoy a little break, and we'll see you at 10:43. Okay, we're gonna get back into it very shortly. I'm gonna give out away a couple of prizes. Random trivia. First one to answer it. What's the capital of Canada? First one to pop that in. I suppose you've got to be back at your computer. Georgina is onto it with Ottawa. Well done. I'm gonna make sure I get to the prize list there so Georgina doesn't miss out there. Yep. And let's go with what is the name of the little piece of plastic at the end of a shoelace? Plastic at the end of a shoelace. Anybody got that one? There we go. Marcus has got it with aglet. Well done, Marcus. And Ritu's come through as well with that almost the same time on my end, so you can have a prize as well. Okay, added those. Well done. Time to get back into it. So Jamie's covered off a whole lot there. We've got that. I want to briefly talk about motorcyclists and barriers, motorcycle consideration. That's useful knowledge, says Damien. Now I'll come back to questions. Okay, I'm not sure if you're still. We need you to let me. Sorry, Jamie, you still there?
Yes.
Did you lose me? Have we lost everybody? No? I think we're good. Sorry? All sorts of fun happening there. Let's try that again, shall we? Okay, you're seeing my screen there, Jamie?
That's good.
Okay. All right, let's talk about motorcyclists. Okay, I'm going to, I suppose, dispel a few myths out there about motorcyclists and barriers, and I'm going to give you a little bit more information about some of the things we can do to assist. Now, here's some research that's been done. So University of New South Wales has been researching motorcycles and barriers for a long time. And you can see there that total crashes for motorcyclists in the blue, crashes involving barriers in the purple, and sort of unknown, which is really associated with the unknown, what was struck when the fatal blows occurred, is in the light colour. So a bit of maybe police reporting challenges there, but these are fatal crashes across different jurisdictions. So first thing to note is that in motorcycle trauma, the association with barriers and being involved is quite low in these fatal ones, and also serious injury. So that's the first thing, I suppose, to note. When you then drill down and say, well, what type of barriers were those ones where there were fatalities and serious injuries? And you see there that guardrail pops out as the big overwhelming majority. And then there's a small amount with concrete, an even smaller amount with wire rope barrier systems, and again, some unknown barrier systems. Now, I'll give a prize for the person who can tell me some of the reasons why they think guardrail pops out the highest. And there's a few reasons. Any ideas? So David's gone underrun. It's not quite there. I'm going to talk about underrun a little bit. No, it's more why we see, guardrail so high up there. Okay, now Glenn has got more where I was kind of looking for. It's used on windy roads. So the other ones are good, and I'm going to talk about those that came in there. But Jamie and Evan briefly sort of mentioned a couple of times there, you can't use wire rope systems on a road with a sharp radius curve, 200 absolute minimum curve for a wire rope system. So you're looking down on a curve here, and if this was wire rope and you put it in and then tensioned it up, what's it going to do? It's going to want to pop into the middle of the road, isn't it? And the posts will bend on these radius curves as you tighten it up. So we don't use it on those popular motorcycle touring routes because we can't. Also, there's another one. There is a lot more guardrail out there on the network, legacy, old stuff, and the like. There's more and more wire rope coming out there. But there are a few, there is some strike of other barrier systems, but guardrails are our dominant one. So just to summarize, a whole lot of research, like 10 years of research from these guys out of the University of New South Wales, was basically a whole lot of different things they were looking at. But they found that when motorcyclists strike barriers, about half of them are on the ground sliding and they're off the bike, or the bike's sort of separated. They hit the bottom of the barrier system. The other half are sort of on the bike trying to regain control. They hit the barrier and they go over the top. Okay. Let's have a look at a few other things briefly, and then I'll show you a couple of things that can be done. So barrier protection treatments, and I'm going to show you those shortly, have a very big reduction in fatal serious injury crashes for motorcyclists with barrier systems. It's quite high, and we can get some good benefits out of holistic treatments, thinking about motorcycles on those popular motorcycle touring routes. So there's stuff that can be done. When motorcyclists strike barrier systems, and the majority of the death is, these are percentages of areas of the body which sustained critical forces. The thorax was the big one, where we're getting that. The head, obviously, a big one as well. But let's just have a look at some stuff here. Hang on a second. I've got to turn my head off so I can play this. So hopefully that played through for you. But this is half of the motorcycles striking barriers. They're trying to gain control. They hit the barrier. They go over the top. Or the motorcycle doesn't go over the top, but the rider does. I'll play it again in case it didn't stream for you. No, I won't, maybe. Now that looks like a very low barrier, far too low, that barrier system, but the mechanics of it are kind of obvious, aren't they? Like the bike will actually do kind of what we want and the reason for the barrier there, but what we're trying to protect actually goes over the top because it's not designed for motorcycles. And here's some motorcycle dummy testing. So you can see on that the bike's doing exactly what we want, rolling along the barrier system. We just lost the rider over the top. So that's about half of them. The other half, as I mentioned, colliding with barriers are off the bike and sliding. So I'll just show you that, and hopefully this will stream through as well. So that's a sort of example there. Lose control, off the bike, sliding. That one was quite friendly. Let's have a look at another motorcycle dummy test here, European crash test. And if there's any thought that the bike might protect the rider, you can see from that one that the rider will inevitably find a post, and the posts don't move the way we see for a passenger vehicle hitting it. The bike manages to sort of knock out a post with its weight, but the rider abruptly stops, and the abrupt stop is what's killing and seriously injuring. I'll get to a bit more discussion about wire ropes shortly in this conversation. So what we can do for the W-beam systems, be that a type BG4 system like this one or a flexible W-beam system, is, as was mentioned earlier, some form of underrun protection. Now that could be something like a rub rail, which this is, or a proprietary underrun system, and I'll show you some of those shortly. And you just want to make sure whatever underrun protection you're putting on, whatever bottom rail you're putting on, complies with the system that you're putting it onto. So you can imagine sliding along here at maybe 60, 70 kilometers per hour as a motorcyclist who's come off the bike for one reason or another to hit one of those upright posts. Highly violent, and we do see some very horrific incidents. But if we were to put that on there, it's still not going to be friendly, but it's going to be more friendly. It will run along the barrier, and the rider will run along the barrier, dissipate energy over time. So a couple of things to cover off in the practical implications of underrun protection, and Debbie's popped one in there. So some wildlife can be trapped. Wombats are the big one there that get trapped in this. So you can, we certainly have created gaps for the wildlife to get in. Koalas, yes, also one where there's been a few challenges there. So those are things to consider. The others are the debris and leaf litter build up, and also snowdrift and some maintenance considerations. But certainly from that rider impact perspective, it's actually quite a lot better from that sliding crash into a post. And they can be retrofitted to existing barrier systems. So the existing old W-beam systems can have this retrofitted with a little clip out, as you can see there. And your proprietary systems also have different proprietary ones, but you'll notice here that it's not on this great terminal here. And the reason for that is that no manufacturer has produced an end terminal that has an underrun protection. And so nothing has been tested. So we could easily add it to here, but we just don't know how that would change the functioning of the system. And you saw from Evans and you've seen now that these are quite specifically designed and tested, and we just don't know whether that would change that. So nobody's done that. So there's nothing approved in terms of a system that directly connects to an end terminal. So if you are out there and you see that a installer has connected stuff to this, that's a big flag, because you could have compromised that system and made it dangerous for passenger vehicles. There is, in Victoria at least, the ability to use a poly buffer system, a plastic product over an end terminal. It's not actually connected to the terminal. It has not been tested either, but it has been deemed that it is not going to impact on the system. So that is probably, if you're really concerned about the bottom of the end terminal, you could do that. So I'll just have a look at a few questions here. So we need some regulations around the use of underarm protection. Yeah, I think some more guidance and the like would be good, and where it's used, and all those considerations that I was mentioning, including the animals and the debris and all of that. So I think that would be a good idea. I know Queensland, has a road safety policy that said it will go on every barrier everywhere, and then they realised that maybe wasn't the best way, so they've come out with some supplementary guidance on the spots that it would be more useful, and some ideas around a few considerations. Is it worth it as grates are on the straight section of the road and lower likelihood of rider losing control? Yeah, I think that's a really good point there, associated with where is your highest risk point for a rider to be leaving the road, sliding and hitting. And in most situations, you're right, that the terminal of the barrier is not in a highest risk location for motorcycle underrun strike. However, occasionally, just due to the way you've had to do things, or there was an access point in the curb or these sorts of things, you do find those situations. It's just something to be aware of. Why have these not been tested? Well, it's an interesting one, and it actually links with the discussion about wire rope systems and motorcycles. And the reality is that the manufacturers, and these are and people designing and creating barrier systems, they are massive corporations worldwide, multi-billion-dollar corporations. They know what there's a market for and what's not, and they know that the risk is low, as you're sort of in the chat there working out, and you go, well, that's probably the bit that doesn't need it. And wire rope systems are just not, they're not the issue that some people make them out to be for motorcyclists. There's So the market is actually not there for them to produce some sort of more motorcycle friendly wire rope system or end terminal with that, because it costs them many millions of dollars to produce a new product, because you've seen the testing regimes and the design and everything like that, and they say there's not a market there for it at this stage. If there was, they'd do it. So not enough important people ride motorcycles. Well, I think it's more that the motorcycle trauma we are seeing is generated from a whole lot of other areas, and we're dealing with a tiny, tiny percentage of motorcycle trauma associated with hitting wire rope systems or hitting end terminals. And maybe we need to address the big picture motorcycle trauma challenges first. But yes, maybe there's a lot of factors at play in that. So there you can see a bit of underrun protection on an X350. I mean, that's got a few little challenges in its own right, that little installation, I would dare say, in terms of you don't like to see an end terminal bent like that. End terminals should be straight. And Jamie talks about flaring them, but that's flaring does not mean bending. That's an important differentiation. End terminals should be straight. Oh, that's not going to work. End terminals should be directly straight there, and flaring them is about sort of having them that way. Anyway, but you can see that there. But what we don't want to see is what you can see down in the background here, which is actually that this isn't just on the end terminal, it's on the whole barrier system. That's not approved to be done. I'll show you some pictures of that later. I'm not going to spend long on this, but there is crash test protocol for motorcycles. It's a European crash test. It uses a modified crash test dummy. The crash test dummy gets very scared of this idea of being used as a motorcycle crash test dummy. Because it's pretty violent event here. Let me show you here, European crash test. Now this is at, so it's done at 60 kilometers per hour, and then the test involves basically sliding the motorcycle dummy with helmet and leathers at the post, and then between the posts. So if you're going to add an underarm protection, you still do those too. So here it's done, first of all, at the post, done at 60 kilometers per hour there. That dummy not only got forces on it that would far and away kill a human, it actually wrote off the dummy. That dummy was a write-off. They had to bin it. Those dummies cost about $360,000 each, by the way. So there's some forces there. So putting an underarm protection, and this is underarm protection. Now you still shoot it at the post and between the posts as well here, just in case there's different deflection. We see the redirection of energy. The rider slides along it. Yes, it gets some force on it, but this is survivable. And I'll just show you here from the top view. There's the first one, dummy write-off, and absolutely enough to kill the rider. You can see that one. You see some deflection in the underarm protection there, the rub rail. So you see it's absorbing energy, and you can see it's also the redirection of energy. So there's important characteristics of that. So that's sort of the underrun part of it. What can we do about the over the top? We probably don't have as many good answers for that. We do have the ability to do some post capping to try to stop snagging and slicing over the top of the barrier system. Some of the proprietary products have your post, and the rail sort of sits a little bit over the top of it to try to stop any sharp edges if a motorcyclist was to be sliding along the top. But apart from that, we sort of don't have a huge number of really great features for the over-the-top issues. Now, the wire rope one. Now, I really, to me, this is a non-issue for the reason that there are so you saw those graphs at the start. There's a small, so motorcyclist trauma is about 17-18% of all road trauma. Within that, only about about 18 to 20% are crashes with barriers. Within that, only about 4 or 5% are crashes with wire rope barrier system. So we're, multiplying that down. It's a tiny thing, but it's got a lot of traction. You've got to give credit to motorcyclists who didn't like this in terms of messaging. They found this, clear, vivid message analogy of a cheese cutter, and then they spread that far and wide. And now everybody somehow thinks this is it. Two things. First of all, it is not anything to do with the wires. Any of those few that we've seen, right? Few crashes we've seen where motorcyclists have engaged with a wire rope system. It is not the ropes. The only one I have ever seen has involved the ropes, and it was basically hitting the terminal, right where the wires are. All the others, and there's only been a small handful of them across Australia and New Zealand, have involved the motorcyclists hitting the posts, sliding, hitting the posts. Plenty of motorcyclists, well, not plenty, we know of some that have been upright, hit the barrier, gone over the top as well. The wires are not, they're not slicing the way people make out. So that's one. The one thing I do agree with the motorcyclists on is that there is no really good retrofit solution for wire rope systems for motorcycles. A couple of other things though. The idea that barrier systems are bad for motorcyclists is incorrect. In fact, they're very good for motorcyclists because they stop other vehicles getting into motorcyclists into the opposite lane. So a central barrier system, wonderfully effective for motorcycle safety. 65 to 70% reduction in motorcycle crashes, or 50% after some sensitivity analysis and those sort of things. But you're seeing huge benefits, right? It's just that, sometimes in that selection of barrier, you've got to be careful. And so really my advice to you, barrier designing, thinking about motorcyclists within barrier systems is, if it's a popular motorcycle route or an area you've got motorcycle concern, don't use a wire rope safety barrier, because you've got a flexible W-beam system available to you, which is pretty awesome for passenger vehicles, not quite as awesome as a wire rope system, but pretty awesome. And you can retrofit it with some really amazing underrun protections for motorcycles. Because a wire rope system like this one, all we really have is a thing called a stack cushion, which is essentially your goalpost padding, your football goalpost padding around each post to try to make it less severe for a motorcyclist sliding. Now we know that is not going to be as effective as some sort of thing to run it along. It'll be effective in some particular crash at a particular speed where we dampen a little bit of energy. But what you're trying to do is absorb energy, not redirect energy along a system. They are available if you need them. I often see them as more a PR device, a public relations device, rather than a sort of really genuine treatment. They will do something in some circumstances, but like take this installation, for example. This was done really before there were any flexible W-beam systems available. Every time now, design this with a flexible back-to-back flexible W-beam system with underrun protection. And it's the same with this one. This is the South Gippsland Highway, the route down to the Motorcycle Grand Prix. So it gets lots and lots of motorcyclists during particular weeks of the year, and the central wire rope system goes in, and the road safety audit comes back and suggests motorcycle protection, and then you pop in the underrun protection there on every post. And I think at the time they were $45 a unit for the stack cushion, the cushion around each post, and that goes on for whatever it is, 5 kilometers, and the dollars rack up, don't they? To me, and it's not even a great treatment if we are concerned about that. These days, this would be back-to-back Easy Guard probably, or back-to-back W-beam system, flexible W-beam system with underrun protection pretty much every time. There's a bit more of it. And then the other thing is to say that there are lots of people coming up with lots of different products, trying different things. So make sure you always go to the product sheet to make sure whatever people are trying to sell you has been looked at, accepted for trial or for use at least. So this is a classic one where they'll probably come to you at some point. It's called the basic system. It's a fabric system that's pinned to the base and pinned to the barrier system, not approved in Victoria, only approved for use in South Australia. We don't approve it for a number of reasons. It's got all those issues we're talking about with animals. It's very hard to put a brake in it. It gets clipped by mowers and different things, and then starts to rip. And it's just it's not a fun system to work with. Just things that are stock standard now. I don't even really need to talk about this, but the delineators being plastic. We used to use metal delineators on top of barrier systems, which really can be a sort of knife edge sitting up as those motorcycles came over. Now we use the flexible systems. Little installation thing I want to flag is connecting the underarm protection to the post. You lose all of that deflection advantage. You've got to have that step out. It's got to be installed as per manufacturer's requirements. And so we were doing post-opening road safety audits of a lot of systems up in the east of Victoria, the windy, popular motorcycle touring routes, and the contractor or installer seems to have realised they can install them a hell of a lot quicker if they don't have to put the little bracket in to sit it out. So just was connecting them straight to the post. We've lost a lot of the advantage there, and also we've created a little bit of an issue, because as a motorcyclist is sort of mashed up against a barrier system at speed, if an arm or a leg can get through a gap, it probably will, and then we've got trouble. So always find the manufacturer's sheet, installation, make sure it's correct. You can see it up there, connect the bracket in, make it all flush. Also, just practical little things. If you've got gaps and things underneath and you can fill those with a bit of dirt and the like, that's good. And also thinking about, just if a motorcycle sliding along here, we're kind of sliding them into a concrete end there. If we can do that, that would be better to somehow design that so it doesn't have that. So I'll answer some questions in a second. Products accepted for use in Victoria. So MPR, which is a proprietary underarm protection, is accepted for use on Easy Guard Smart, Biker Shield on Ram Shield, Rider Pro on Century W-beam. So you can see how each proprietary manufacturer has their own proprietary underarm protection there for motorcycle safety if you elect to add it. Product conditionally accepted in Victoria. So MPR on Type B W-beam. So that's the proprietary product from Ingal on a public domain system. So that one has been conditionally accepted. Public domain rub rail on public domain W-beam, and poly buffer, as I showed you before, on terminals only. We don't want to see that. That's the poly buffer being used as an underrun protection in its own right. Hasn't been tested. Also not the most elegant sort of connection in my mind, using essentially zip ties to connect it to the post. I think we could probably do a bit better than that. And so, we've got the stack cushions, which, as I say, it's kind of your last resort. Don't expect a huge amount out of that, but be aware they are there. In Victoria, really is the only state that uses them in abundance. There are a couple of individual post protectors available that you could use, conditional use. Bicamate, it's just cushioning for a single post, and impact protect, so around an individual cam like that. Again, you're trying to sort of absorb a bit of energy. Football goalpost padding, it's not the most beneficial, but it's something. Any questions there? Stop sharing. Let me just go through and have a look. So yeah, I mean, some people talking about the inherent dangers of riding a motorcycle. I think we, as sort of managing an entire road network, we do license and register motorcyclists, and that's sort of giving us a duty of care in managing the road system to do what we can, taking into account, that there's not infinite funds out there, and we need to target our funds at the highest risk. So we do need to consider this. In Victoria, there is a list of sort of 200 routes which are considered the popular motorcycle routes, and they really should be treated with underrun protection on the barrier systems and barrier selection choices based with motorcyclists very front of mind. But any route, you should be thinking about motorcyclists in your selection of barrier. It's one of the many sort of things you need to add into your consideration when selecting the barrier type, and then any retrofit devices you might add to it. Okay, I think that's about it from there. Something's in the Q&A, and Dale, Mark, and Darren, if they're gone with most common, which refers to the W-beam system. So I'll add, I don't know who it was, so you're all going to get a prize. Dale, Mark, and Darren. Any other questions on motorcycles before I hand back to Jamie, who's going to show you some real world examples, I think, and a few other things of, well, like bad installations. And I think we can learn a lot from bad installations, and some have caused some injuries and some issues, and some are just identified beforehand. But any questions there? Okay, over to you, Jamie, and we'll see if there's any time at the end for some other questions or comments.
Thank you, Ken. I'd like to share with you now my thoughts and some common examples of installation and design issues. These have been identified by us at Safe System Solutions and DOT through our experience with barrier installations. Also, I've got a few road safety audit comments thrown in there from projects that we've audited. Now, there are a range of common causes of issues associated with incorrect or less than ideal barrier installations. Often it's a team effort between a number of these different parties. The new products coming onto the market are increasingly complex. It's an evolving area. Installers have a range of different products that they need to be familiar with, typically with lots of different parts and so on. That has created some issues. Suppliers in the past have been guilty of providing insufficient guidance around their products. That has certainly improved. Designers may not have had an adequate understanding of the products that they're designing with, or may not be familiar enough with the site to prepare an adequate or an ideal design. Installers and contractors may not be familiar with the products, and the road authorities in some cases, particularly through a lack of supervision during the installation of products, has meant that some otherwise avoidable errors have slipped through. So I'll step through some of those common issues now. There is a bunch of common proprietary products. These are all now superseded products, but probably some of the main culprits when it comes to installation issues. Each one is different, lots of different parts and so on. Lots of installation issues have presented with these, especially early days when these products came onto the market. So when it comes to design, inappropriate choice of barrier system or terminals, you can see there a lot of the common issues that often occur, and I will show you photos of most of all of these. So I'll skip through to the photos now. Similar to the example that Ken showed before, we have an inappropriate transition here at a bridge barrier. So there's an exposed end there that's a hazard to errant motorists or motorcyclists that might strike that. The ideal situation would be, I guess, an integrated transition, maybe where the bridge barrier terminates at the concrete end post, and there's an appropriate transition of stiffness, a direct transition between those barriers. Here we have a two-way carriageway, and the decision was made to install a trailing terminal on the departure end, a situation that has commonly occurred in the past, based on clear zone thinking, that this terminal is outside the clear zone for the direction of travel in the lane furthest from the terminal. The preference now would be to install a grate, because there certainly is that potential for an errant vehicle to strike that barrier end on. And if we were doing that, it would be desirable to extend that barrier further towards us to entirely shield that gabion wall. This terminal is a gating terminal. There is potential for an errant vehicle to pass in behind here and snag on that wall. A tree located within the barrier deflection zone and its working width, a heavy vehicle that struck the barrier or pulled over at the roadside there may well strike that tree. That said, this is a guard fence that's a TL3 barrier at best, so it wouldn't be expected to contain a truck. So providing a working width would be not the norm, or would be a generous thing to do here. Distance between there, metre, if you're lucky. It doesn't appear that the system has been stiffened up. So in this situation, in the least, we should be looking at reduced post spacings to stiffen up the barrier system to minimise the likelihood that an errant vehicle snags against that tree.
Yeah, so certainly, I mean, I think it's, when Debbie sort of said that probably had an exemption, which is probably doing everything possible to not disturb the tree, but as Jamie said there's lots of ways to lessen the risk for drivers in terms of closing up post spacing and playing around with that sense. And Damien causing trouble there, saying to cut it down. That's not what we're looking to do at all.
As I've mentioned before, it really is a balancing act a lot of the time between providing some shoulder space here a good barrier offset, and adequate space for deflection. So we could shift that barrier further away from the tree, but that comes with its own increase in risk. This wraparound treatment or short radius curve treatment is something that's accepted in Victoria and in other states. You can see the timber posts here with the holes drilled out. They're intended to yield if a vehicle strikes on this radius. To operate properly though, you need a nice clear area in behind. The idea is that an impacting vehicle, the barrier deforms around the impacting vehicle and contains it within this sort of area. So there's certainly very little scope for that to happen here. So that treatment isn't going to operate to its full capability.
Can you go back one, Jamie? Sorry. Or back two now. They're just pointing out that the pole on the other side, the power pole there, and it's pretty close to the road there, and doesn't have any protection. And then the old put the width marker on it as a bit of an attempt to try to do something.
Yeah, it's a great pickup. It is very close to the road. It's pretty much at the edge of shoulder. If you were to shield that with a barrier, you're going to have not much of an offset at all. It's just in advance of the driveway, so you'd be compromising that shoulder width and the ability for someone turning into that driveway to just pull off the road before turning in. Really tricky situations, those ones. You might look at a point protector like a Raptor crash cushion, depending on the speed environment.
Yeah, I've given Tim a prize for his eagle-eyed look at that one.
This is the old way of doing things, where we put the barriers as far from the road as possible. That is a real, fairly gentle and smooth batter. But it does open up the opportunity for those higher impact angle crashes and also a rollover before a vehicle strikes the barrier. We've got a bit of a table drain here. We've got a curb here. So there's a few things happening that mean that the vehicle trajectory is going to be a bit, could be anything, reducing the likelihood of that barrier performing as it should. So the preference these days would be to locate the barrier up here, probably at the back of curb. Although that said, we're then looking at an offset that's probably not desirable, but subject to our offset to curb requirements, we'd more than likely locate the barrier up here somewhere. This product, and I wonder if anyone can name this one. I don't expect that you can, but we'll certainly give you a prize if you can. This was one that wasn't on the VicRoads accepted product list, but someone did a good sell job to a contractor and one popped up on the network. So it does happen on occasion. If you're approached by anyone trying to sell you some U-Butte new product, always check that it is on the VicRoads accepted list.
So while people
coming through,
we've got Thribeam as a guest, which is it's not Thribeam. It's a particular end terminal type. As we do that, interesting point that was made about poles and trees, and it's a really interesting one. We don't. People are very reluctant to do anything around a power pole, and a tree is often more, we could cut that down or the like, but nobody would ever, they think very differently about that. But we can certainly move power poles and underground them and all sorts of things. So, yes, it's expensive to touch them, as many of us know. But no, I don't think anybody's got that one, Jamie. It's a pretty obscure barrier system. end terminal, but what is it called?
We'll have to jackpot the prize. This one is the Minnesota Bull Nose. So it did appear on the Victorian network, but never has and never will be an accepted product.
Yeah, and I think the point you made there, Jamie, is a really good one. And I sort of made it a little bit with that basic fabric barrier motorcycle protection thing, is that products come along. Always check your product acceptance sheet for your jurisdiction you're working in. Always. Okay, over to you again.
Here we have another situation. We put the sign on the pole again. That's the old favourite treatment when we can't think of anything better to do. A barrier has gone in front, offering some protection from the pole. Clearly the deflection space isn't what we would want. The barrier has been stiffened up with reduced post spacings. You can see that through there, but it is a wire rope, so its deflection still will be great. This would have been, a better treatment here would have been to adopt a guard fence barrier with its reduced deflection and still stiffening up the barrier with reduced post spacings. It's a build-up environment. I'm not sure what the speed limit is here, but it could be as little as 60, perhaps 70 or 80. So we're not likely to see those MASH TL3 impact conditions. So its deflection isn't likely to be, at the full extent of the values that we assume for design purposes. But even still, a guard fence product would have been a better choice here. A guard fence providing protection to some hazards, but there's quite the opportunity for an errant vehicle to pass in front of that barrier into the trees here. This is something that is commonly seen at transitions from cut to fill. They're particularly tricky locations, and you can see the cut batter here. I suspect the barrier stopped where it did for access reasons, to provide access to the roadside here, where there's a relatively flat roadside. We perhaps couldn't have extended that barrier in front of the cut batter due to a lack of space for deflection. Regardless, there are exposed hazards in the roadside, and from a safety point of view, it would have been preferable to extend that barrier further to shield more of those hazards.
So question there was around the drain curbing around the barrier end terminal there. Any comments on that, on the previous one?
This one?
Yeah.
Yeah, you can see it. That's sort of a channel section that's popular in New South Wales. This barrier is in New South Wales. Look, it's a fairly shallow sort of profile drain. The barrier is sort of set back a little back from that channel. So it's sort of probably not in accordance with our zone, one preferred location, but I wouldn't expect that cross-section, that channel cross-section, to have a big impact on vehicle trajectory, but it would have been preferable that the barrier be located as close as possible to the back of that channel.
Yeah.
I mentioned this one the other day. It's a back-to-back guard fence in a particularly narrow flush median, a 1.4 metre wide flush median, which is, have been installed at a number of locations around the state, sometimes with wire rope, sometimes with guard fence, and with an increasing preference for back-to-back guard fence for maintenance reasons. An issue with that is the need to use these particularly wide median terminals. Now, I will point out that that's not a MASH accepted terminal, but to this day is the only available guard fence terminal for median applications. So the road design note talks about seeking approval from DOT, the Safe System Engineering team. but this is the one that you will need to use until a MASH accepted median product comes onto the market. It is particularly wide, very little room for error approaching that terminal. This is a 100 km/h environment, and that particular terminal was taken out very, very soon after it was installed. You can see it's not particularly well delineated. There are a few RRPMs, and that's about it. I don't believe there are any signs in advance of this location advising of the situation. There have been a lot of lessons learned around the application of barriers in narrow flush medians in Victoria. This wire rope was struck and a very long distance barrier flattened, whilst still under roadwork speed limits. So presumably a heavy vehicle has taken this one out, and it really does point to the need for a high level of delineation at these locations. Now, around Victoria and the country, a range of different things have been done. Here are a couple of examples. You can see the Clemfix paddleboard arrangement and keep left signing. This might be the Melba, is it, Ken, I think?
Yeah, it's Melba. Yeah.
On the right, a treatment popular in New South Wales with these plastic cones that are used at the start of wire rope terminals in medians. So both of these stand out fairly well. You can see there, just through the use of wire rope, there is it's a narrower system which can help in that situation. Another one that I quite...
Sorry, finish off talking about the approaches, and then I will go back and we'll address some questions.
Another one that I've seen and quite like is this arrangement with a series of these sort of small frangible bollards that sort of have provide a good visual cue, but also a tactile cue if you were to drive over them, drive into the median, approaching that barrier. So this is another treatment popular in New South Wales. In Victoria, we sort of tried a few different things. There wasn't guidance there for a period of time. There now is in the road design note around central barriers in narrow flush medians. So there are preferred arrangements now that provide a high level of delineation, a localised widening of the median around the terminal, and where possible, a raised island as part of that arrangement.
Okay, go back a few and look. Somebody pointed out a big green sign on the other side of the road that looks quite hazardous. Yeah, might be that one as to whether it's frangible or not. A bit hard to see, isn't it? There are different sign support structures in a road design note accepted for use in Victoria as well, so be aware of that. There's also some products to hold up those signs and others that have been deemed to comply with MASH, actually, some of them, and some other test protocols as well. But MASH is the Manual for Assessing Safety Hardware. It's not just barriers, it actually contains some other products as well, hardware. So we'll jump on from that one. Question was, what is the difference between a median terminal and a left-hand side terminal?
So with this, so a median terminal needs, well, in the case of guard fence, it is a terminal that can terminate a back-to-back installation. And it needs to be crash tested and able to withstand impacts both end on and from the opposing direction of travel, if that makes sense. So if this car that we can see there was to strike the barrier or this, the far side of the terminal, it needs to be able to withstand that impact. This is the X tension median terminal, which is very similar to the X350 left-hand side terminal, except that it has some additional components and just caters for that back-to-back arrangement.
A couple of things on. Actually, you've got some examples of installation of these systems, don't you, coming up? So I won't go into that in detail. So if you've got a back-to-back system like this, do you do your working with calculations on assuming it doesn't have that second rail, or do there specific deflections for back-to-back systems? How does that work?
Yeah, good question. Your working width is typically measured from the face of the barrier on the side that you're expecting it to be impacted. As far as I understand, these arrangements, we would typically adopt the same working width as we would for a single-sided arrangement, although, sort of logically, I would think that they would perhaps deflect a little bit less. There's that little bit extra resistance. So, you would measure your working width from the face of the barrier on the side that it's to be impacted on. And a question that often comes up is, do we need to contain that deflection within the median? And in a 1.4 metre median, we certainly don't. You need to think about the risk of, if that barrier is struck and it deflects by around about the crash tested amount, what's the likelihood that a vehicle is coming the other way at the wrong time and is in that exact location, which obviously depends on the number of lanes and traffic volumes and so on. And I think the risk is, or the likelihood is particularly low that the vehicle will be in that wrong spot at that split second. So we typically don't design our medians to accommodate the full deflection.
Yeah, no, it is a good question there, and that does seem to be the way that it is done. The next one, back in the New South Wales, the big yellow block of a thing at the end of the at the start of the system. I mean, that's plastic, isn't it? That's just
it's a frangible plastic cone cylinder.
So it looks scary, but it's it'll just break away very easily on impact. Just there as a plastic cone. Okay, let's keep moving along. Keep your questions coming in. This is good. You're seeing real live examples of some things, and you've got some more coming up after a few notes here.
So the issues that we've just stepped through, predominantly related to design, or could have been addressed at the design stage. At the installation stage, a few things that commonly go wrong are listed there. And again, I will show you some photos of each of those things. They relate to the barrier height, maybe the positioning of posts. Often things are encountered on site that perhaps the designer hadn't envisaged. There are often surprises. And on that, if the installer decides to make a change to what has been designed, they shouldn't take that responsibility upon themselves. They should refer back to the designer and seek their advice. An installer may think that they can install an alternative solution or do something a little bit differently. There may well have been good design reasons why the designer had done something a certain way. So there should be that feedback to the designer. And the installer, if they differ from the design, they're effectively taking responsibility and legal responsibility in the event that something happens and goes wrong. So a whole list of things there that can go wrong at the installation stage. What's happened here? For a prize.
For a prize. What's going on here? Why? Oh. Yep, Damien was just in first with Rock. And
spot on.
Amanda got Rock as well. Glenn, so I'll give out a few prizes for Rock. I think that's what there was. A few others had some ideas which were possible, but I would say it would be Rock. Is it Rock, Jamie?
Yeah, Rock. It's Rock. Yeah, Rock was encountered posts were driven as far as they, until they struck rock. What did the installer do then? They just went through and cut them off at the top of the rail height. So that is a no-no. We should be drilling into rock and ensuring that those posts are installed to the required depth to ensure that the terminal will operate as it should. So these couple of posts here, there's sort of another, 700 mil or thereabouts they could have and should have been embedded. So, they're not far into the ground at all, maybe half a metre down, something like that.
Now, I think the important thing for people to remember on this is that with a Type B G4 style system, the post is providing a structural, really important part of the way the system works, whereas the flexible W-beam systems is the posts are breaking away more, so they're a more flexible part of the system. But even still, you want to get it into the ground. Yep. Okay.
This is a view of the back of an X350 terminal. It's a now superseded product. It's a great product, not accepted to MASH, but it's a very good one, but did present more than its fair share of installation issues. And one that you can see there, relates to the tension in those cables at the back of the system. These cables anchor to the ground here and also to the back of the rail at the end of the terminal, about 15 metres to the left. The lack of tension in the system, look, they're not required to be tensioned to any particular level, but they should be reasonably taut. When that barrier is struck end on is when that level of tension would, side on is when that level of tension would come into play. So there's going to be a bit more give in the system in this situation. But the fact that they are as slack as they are sort of points to the fact that the whole system hasn't been been installed probably as it should be. Post spacings, will be outside tolerance levels. It's a pretty unforgiving system to install. There's only about so much thread at the end of the cables at either end. And if you're outside that, you just can't tension it up as you would like.
I'm going to give a prize to Mohammed on a completely off-topic little thing there. Has picked Santa in the background. So that's, I'm like, what on earth is, there you go. No, but I think the complexity of these end terminals, especially like this one, it takes a while to get your head around how they actually operate. And the fact that, as you say, the looseness of that wire is not good, but it's not required to be in tension because it's not tensioning. It's the system sliding along it and grabbing it as it goes. Have you got? I think you got a picture of that, don't you?
I've got a picture of that coming up. Yeah, the way this works, if it's struck end on, is that there's a mechanism inside underneath this cone that grabs those cables, and if the vehicle strikes it going that way, there's a lot of friction developed between the cables and that locking bar, and this whole unit will slide over these cables. So the lack of tension beyond this point sort of is not that important when struck end on. And I have got a photo coming up. This is the same terminal system, and this is what's referred to as the slider unit. So the X350 operates with rails sliding one over another as you move away from that impact head. So this rail here slides over this one, and this slider unit facilitates that. This angle bar, it's called, its function is to knock these black plastic blocks out of the way as that terminal sort of slides over itself. A common mistake is to install this angle bar on the wrong side of the block. So the impact head in this case is to the right, and the whole system will sort of slide over itself towards the left. So this bar should be over here to knock these blocks out of the way as it does that. This is the site of a fatal crash where a four-wheel drive left the road. I think it's the Western Highway or Freeway. Left the road, a vehicle with a higher centre of gravity in it. It struck this Type B guard fence and went over the top and resulted in fatalities. The contractor charged with attending to the barriers saw fit to straighten out the posts and reuse them at this location. So you can see that it's significantly weakened. Obviously, the barrier hasn't performed as we'd like in the first place. So that's a really poor outcome. That should have been in the lease replaced with new components using the same system or upgraded to a currently accepted product.
Debbie says unbelievable. I agree, and certainly others who have or the officers in charge when they discovered it were also not very happy with this at all.
This is the ET 2000 Plus terminal. Another now superseded great, but a great product. Didn't present many issues. The key issue associated with this product, though, is pictured there. I wonder if anyone can spot it.
Yeah, let's see if anybody's got any ideas. What if you were doing installation inspection on this this barrier? Would you point anything out? Are you happy with it? This sort of proves that each system you need to get to know it, and there are the suppliers and manufacturers are coming better now with manuals, with videos on how they should be installed, and with examples and those sort of things. So so you can get a lot of info. What do we got here? Front panel round the wrong way. The top of the post is exposed. Is that you? Channel installed the wrong way around. The end of the W-beam needs a cap. End terminal, not quite. Where sharp edge exposed.
Getting closer, I think.
Well, that's an interesting one, because in Victoria, we do put a motorcycle protection cap on the end of the two prongs out the end, basically. Those are there to sort of grab a vehicle to a degree, but we put the motorcycle thing on it in Victoria, but that's not the thing that's going to cause a lot of trouble here. WD not installed.
There it is.
Yeah, so Hamantha's got it. You explain that one, Jamie, and I'll add that.
You can see here that the end of the W-beam is sticking out. It should be contained within this extruder head. So this is an extruder system. It operates when struck end on here. That extruder head sort of pushes its way along the rail. This rail feeds through this head and is spat out to the side. So if that's struck end on, there's every chance that rail will spear out towards the roadway and the vehicle rather than pass through the extruder head.
Sorry, I'm just reading back through comments. Lots of people getting prizes, and some people I may have read a couple slightly wrong. They had that same one, but anyway, let's keep going.
Ken talked about post protection for motorcyclists earlier. Here's an exposed end of one that does present a hazard to a sliding motorcyclist. So it's unclear whether this is perhaps the end of a terminal, and we can't extend that along there. But in any case, there is a risk there to a motorcyclist in particular. This barrier is clearly not going to work. It's concreted into the ground. I can understand how this has come about, sort of. Where barriers are located in close proximity to curbs, the height of those barriers should be measured relative to the road surface level. So the asphalt here, rather than the ground level at the top of the curb. The effect of that is that the barrier in the terminal sort of needs to be recessed into the ground, if that makes sense, because relative to the surface level, or the level at the top of the curb, the barrier is lower. And that's because an impacting vehicle hasn't had the chance at this location to have increased its height. Its trajectory hasn't changed because the barrier is particularly close to the curb. So what often happens is that where an infill or a maintenance strip is provided like this, it's boxed out around the terminal, and that sort of recess is left. But in this case, they've seen fit to fill the whole median in there along with the barrier.
So, yeah, a couple of points on that, and just reinforce there Jamie's comment about measuring barrier height off the road surface, not the up where that curb is there. That's an important thing to measure, and barrier height is a really, I think, an important thing for us to always to be considering. And I think you'll be getting a barrier height measuring stick from us in the mail with your prize and the like. So you'll be able to do that. But the second question here on that is that in a median? And then I suppose the following question, and if so, why are we not using a back-to-back system, or is that like protecting a bike lane or something?
Yeah, I'm not sure, to be honest. This is a photo that I inherited from Evan. It's not clear. It's probably more likely in an outer separator, or perhaps between a traffic lane and a bike lane. I'm not sure, but if it was in a median, you're right. You'd want to be installing a median type terminal. Sometimes we encounter things on site that mean we can't install posts where we might like to. And on occasions, we use some extra blocks. This is type B guard fence, which typically has a single block out. I think guidance tells us that we can go up, we can use a couple if we need to. This is a bit excessive. I think we've got 5 there for quite a few posts. It's hard to know how this barrier might perform if struck. I suppose there's a chance that if it's struck, and it rotates as they are intended to do, the posts sort of rotating the ground, this rail height might increase. There's perhaps an increased likelihood of the rail disconnecting from the post at some point, and the barrier not performing as we would like.
Yeah. So it's certainly pointed it out on that one. But do you think that they're just unaware that there were services under there during the design, and then an on-site bit of jimmy rigging to get something together?
That's probably right. Yeah, looking at the design stage, typically a dial before you dig might be done. So the location of services would be based on a dial before you dig, and also observation of pit locations and the like on site. So it's approximate. Then there might be a bit of a service conflict analysis done, and locations where there are potential conflicts would be identified, and you might look to prove the services in those areas, and often they're not quite where you expect, and things like this can happen.
Thank you.
This is a bit of a makeshift repair job at a terminal. You can see a cable going over the top of a post that is not anchored at all and not where it should be. This ground strut doesn't appear to be connected appropriately either. Again, we have an installation just behind back of curb, which therefore sort of appears to be lower, which might be a source of some of those issues.
Yep. There was this question about, or back on the one with the 5 blockouts or whatever around the sort of softness of the soil in that as well, and that is a thing that is considered in barrier installation and design and the like, isn't it? How solid your soil is.
Yeah, that's right. I guess there's sort of an assumption that the ground conditions are sort of in line with typical conditions. That's what sort of barrier products are based on. So if you have something out of the ordinary, some soft fill material or whatever it might be, then you might want to think about using longer posts or closer post spacings or something like that.
Yeah, so there is a test for that, isn't it? Where you put a post in and you push it, and I think though that the test is usually done with backing the ute into it. In
That's my understanding. Yeah, there is do they call it a lateral load test or something like that, particularly for wire rope posts to test the adequacy of the concrete footings. There are specific details around the test, how the test should be done with the amount of force, but in practice, I think it's, as Ken says, someone backs a vehicle into it and sees what happens.
Some points on getting more structural integrity around the soil with ground covers and the like, which I think is always a good thing to be looking at. And the ET, so the ET 2000 terminal there was bolted down, and there may be some lead time for fabrication. So you can get bolt down terminals, can't you?
I think you can. Yeah.
Okay, let's keep moving on. I think I've covered most of those.
Barrier height. It's frequently the case that older barriers are not in accordance with current height requirements, and particularly guard fences. You can see one here measuring in at 600 mils. The standard height of Type B guard fence increased a few years ago to reflect the increase in sort of size of the vehicle fleet. And with the transition to MASH and the adoption of test vehicles with greater mass and higher centres of gravity, the heights of barriers has generally increased in recent years. Also, what can happen on the network is with resurfacing works, the effective height of barriers decreases as pavement layers are added. If you do encounter guard fences less than the standard height of something like 740 mil, you can increase the heights of those barriers using Abraham blocks. So that's a specific type of block that can be retrofitted in place of the standard blocks to increase the rail height. This is the location of another fatal crash where a vehicle, and again it was a four-wheel drive with a higher centre of gravity, wasn't contained by the vehicle, went over the top. When we measured this height, we found that I can't recall, but it was certainly no more than 600 mil high. You can see there a fair build-up of gravel and debris, which has contributed to that barrier being lower relative to the ground surface at that location. It's an older barrier. So yeah, barrier height certainly is important. So if you're dealing with a project that has some existing barriers on it, be mindful of the heights of those barriers, and particularly guard fences, and look to raise their height using Abraham blocks, or alternatively replace them with a system that's currently accepted. The ET2000, again, and similar to an example Ken showed earlier, this terminal is curved, which is a big no-no. We really can't be sure that that system will perform as it should. Another thing that I'll point out is the rail overlap direction. You can see here that the second rail, sort of moving away from the impact head, is on top of the first rail, and you can see a bit of a gap opening up there, which is being caused by the kinking and the curving of that rail. So as those rails feed through this extruder head, there's an increased likelihood that this one will snag on this part of that extruder head. Now, the supplier of this product states that the rail overlap direction can be installed either way for this particular product. So the first rail on top or underneath. For other products, it is critical that the rails overlap in the direction moving away from the impact head. So in Victoria, the approach is for all systems, to avoid any confusion, for all systems, we install those with the rails overlapping as you move away from the impact head. So this is a common overlap situation that is installed on the departure side of terminals, because installers think that no, we always overlap sort of in the direction of travel, and I hope that makes sense. But the exception to that is where we have great terminals on the departure end of barriers. The rails within that terminal should be overlapped as if that terminal is being struck end on. There's a wire rope barrier terminal footing that clearly is lifting out of the ground. I'm not sure whether that's because it hasn't been installed to the required dimensions and therefore mass and depth. This is an aspect of barrier installation where it's critical that there is surveillance to ensure that these things have been installed as they should be. And here's the photo I was looking for the X350 terminal. So looking down on the top of the X350, we have this element here, which is called the locking bar. And if you look closely, you can see the cable running through the terminal head. This locking bar has two holes in it, one for each cable, and the cables pass through. So initially the cable's rotated something like this. We then tighten up these bolts on the side to rotate that bar to a position like this. And the result of that is that the cables that pass through here are kinked through that locking bar. So if the terminal is struck end on, the locking bar moves along those cables with a huge amount of friction that brings that vehicle to a controlled stop. In the situation on the left, where the bar hasn't been rotated, the cable just passes freely through that locking bar, so there'll be very little resistance, and the vehicle is likely to reach the end of the terminal without washing off very much speed at all, and potentially come to an abrupt stop or even spear at that location. This is a common installation issue that installers neglect to rotate this locking bar from this position on the left to the required position as shown on the right. Another instance of wire rope footings lifting out of the ground. These old pile top footings are no longer accepted. Now we only have sort of mass rectangular blocks. And they are very hefty lumps of concrete. This one certainly isn't in accordance with the dimensions of a footing as required now. There's something like 2.6 metres long. Not sure what's happening here, but it appears to be someone's attempt at an intermediate anchor. Sometimes with wire ropes, we decide to create a break or provide these intermediate anchors in order to avoid having an installation of excessive length. It might be because we're about to enter a curve and we're mindful of deflection through the curve. It might be because we're exceeding that maximum length requirement for the barrier. The suppliers do provide typical details for these intermediate anchors. They're basically an overlap of two barriers with two terminals. It's required that the points of need are overlapped, so there's no opportunity for a vehicle to pass into the roadside. And there's also a minimum requirement, a minimum distance between those barriers, and that's sort of approximately equal to the deflection of the system. These two would be very close. They'd be basically touching each other.
Jamie, back where the footing was lifting out, do you think that was from an impact or just from the tension itself?
I don't know, but I suspect it's just from the tension itself.
Yep.
Another wire rope anchor point. It is a requirement that the anchor is located centrally within the width of the footing. Within the concrete, there's a reinforcement cage that requires a certain amount of cover. So this anchor should be located across here, centered in that space. Again, I can understand why it's been constructed this way. Where you are behind curb, the concrete footing is, I guess, sort of off center relative to the alignment of the barrier. So to locate that centrally, you would have to adjust the barrier offset up here, or kink the alignment around sort of after the at the terminal. Not sure if anyone can pick the issue with this one.
Yeah, okay, so we'll see if anybody comes up with anything. You'll have to look closely, I think, there at the picture and along there. There we go. I think Glenn's got there. Joining different wire rope safety barrier types.
Good spotting. So you can see in the foreground here, we've got a system, a 4-rope system where the lower cables sort of weave around the post, connecting to another system with 4 vertical wires. So that's a big no-no. We can't be sure that system will operate as we would like. Not sure what's happened, whether someone just had, certain type of posts in the back of the ute, although now that I look closely, I can see some older, perhaps some older post footings or an anchor point there with some teeth. So this might have been the end of a barrier system that has been extended, perhaps. And in that case, the same product should have been used, or the old portion of the barrier replaced with one that met current standards.
So both of those, though, are accepted or were accepted products, with the one with the weave and the one, it's just you can't join them together like.
That's right. They've both been accepted in the past, although at different times. This Bryphon system became legacy before the flex fence system did. So it may well have been the case that this barrier was in place and it was decided to extend it. It wasn't an option to use that system, so they've used what they could. Another common issue at wire rope terminals is the installation of this anchor bracket. You can see this sort of fin here. That's provided as an installation guide. It should be parallel and flush with the ground surface, with the concrete. You can see in this occasion, obviously it's protruding, and it's also not level. The whole anchor bracket is sort of kicked back, angled back, and the result is that there's an increased likelihood of these cables popping out under the tension in the system, or perhaps on impact. So if it had been installed correctly, that entire arrangement would have been sort of angled sort of back more. The teeth would have held those cables better. The top of the fin wouldn't have been visible, or may have just been visible above the concrete. Another common scenario is the installation of barriers at the hinge point. And it's particularly an issue with wire rope because that system requires a greater verge width for lateral support and to accommodate some of the deflection of the barrier. Here you can see that it appears some formation widening has taken place. It looks like we've got some pretty soft film material here, maybe a bit of erosion happening, and the barrier is very close to that hinge point. So, yeah, I'd suggest that the verge there is not going to provide much lateral support, and the barrier is going to deflect excessively out beyond that hinge point. Someone's poor attempt at a repair job that's not going to stand up if impacted. This is Donnybrook Road near Melbourne, where a lot of barriers were installed going back 8 or 10 years. A huge rainfall event happened soon after their installation. There was some widening work that took place at the same as part of those works. And a lot of that widening just washed away, resulting in some exposed wire rope barrier terminals. You can see the erosion here. The barrier now is right at the edge of shoulder, and there's a drop off there. So we don't have the support required to that system. So perhaps that's inappropriate fill material, lack of compaction. Not sure what it was. Maybe it was just a weather event, one out of the box.
People weren't too happy with how close it was to the swale drain there as well.
Another height-related issue, and you can see our high-tech device there that we've used to check the cable heights. Each of those cables should be at the black line on the pink tapes. It's higher than it should be by 70 or 80 mil perhaps. This we frequently observe where wire rope post footings are mounted up excessively. They should be constructed so that water sheds away from the sleeve, but it's often the case that they are built up that bit too much. And that's been the case here. What does it matter? Barriers being too low is a bigger issue than barriers being too high. Perhaps in this case, there's a slight increase in the likelihood of a lower vehicle underrunning the system, nosing underneath those wires.
A question, comments come in, and it's around what's the tolerance for that difference, and it depends on the system, doesn't it?
Yeah, it does. It's typically plus minus 10 or 20 mil. There's not a great tolerance there. And yeah, and there needs to be a bit of flexibility. The ground conditions sort of vary and go up and down here and there. So, but yeah, it's a common thing we observe that those footings really are mounded up excessively.
Yeah, and we, as I mentioned, we'll send you all out a much more advanced version of the stick Jamie's got there, which has actually got different system heights and the tolerance marked on them, and slip base bowl, light bowl, height of the shearing plane and tolerance off that, and a few other things. Because the most annoying thing is out there doing an audit or a check of a system and trying to measure and think, well, what was the tolerance on that one, and how, so having the stick is just an easy way to do it. Can it have a bubble level 2? Well, yes, of course it can. And even a little place to put your phone, so you've got an electronic level and you can tell slope grades and the like. So we've thought of it all, and you'll get that in the post.
This photo shows a tension bay partway along a wire rope installation. These systems are tensioned upon installation, and their tension should be checked over time. Tension does vary with temperature in particular. Impacts can affect the tension system and require them to be retensioned. When they're installed, it is desirable that the cables look something like they do on the bottom turnbuckle there. So a good amount of thread protruding on either side, which provides scope for the system to be tensioned or detensioned as required. On the upper cables here, you can see that the threads, they're sort of fully wound up. There isn't very much or any scope to further increase the tension at that location. Drainage assets do present us a number of challenges with installing barriers. We often need to omit a post to straddle bigger culverts like this. There's often, erosion issues. We need to be pretty careful with how and where we install our posts. I'm not sure what this one in the middle's sitting on or has been rammed into. It may have been cut short, I suspect. And clearly there's a lot of erosion happening here. Not much lateral support provided to the system at that location. A little culvert or two hiding there, and a post has been driven into it. So we do need to be mindful of these types of things, adjust our post locations and spacings accordingly. As a general rule, it is permissible to omit one post for any barrier system, wire rope or guard fence. But where we're doing that, we need to think about whether or not we need to take other steps to stiffen up the system at that location. If there are point hazards behind the barrier, like a tree or a pole, then we certainly should. If there's a relatively clear area and we accept that the barrier might deflect a little bit more, then there's perhaps no issue. In this case, we have a culvert. We have a post omitted mid-span here. That's been compensated for by double nesting the rail. If you look closely, you'll see there's two or even a third rail through this span. And the post spacing has been closed up on either side of that culvert to really stiffen up the system. So those are issues all related to permanent barrier installations. When it comes to temporary barriers, there's a different suite of products and a different list of typical issues. And some of those are listed there, and I'll show you some photos. It is commonly the case that temporary barriers in built-up environments are used as much as a delineation device or a pedestrian fence or something other than a road safety barrier. In this case, you can see some steps. It's sort of part of a scaffold arrangement. We've got a fence there. I certainly wouldn't want to be walking along the top of that if that's struck by an errant vehicle. Another example there of a mismatch of different products that are probably not connected. They don't form a continuous longitudinal barrier that is going to contain and redirect a vehicle away from that work site. The addition of the fence on top is another no-no. We can't be sure how that will behave. What do you think about the sign being located in front of that? It's a temporary barrier located there without a terminal. Any errant vehicle that struck that end on will spear or snag on the end, resulting in a serious crash outcome. So it appears that sign has been put in there to sort of flag the issue and try and encourage people to stay away, but that barrier certainly should have been terminated with an approved terminal. Another instance of temporary barrier products being used as some sort of delineation device, obviously not continuous. It's a bit of a delineator between the sort of pedestrian area and the adjacent bike lane and traffic lane. A practice that was more common in the past was to flare temporary barriers away from the road such that the start of the barrier was located outside the clear zone, and in doing so, not install a crash-worthy end terminal. It was assumed that most vehicles wouldn't travel that far from the road. That's not how we go about things anymore. That barrier, regardless of its position, should be fitted with an accepted end terminal. An overlap of temporary barrier systems there, a plastic system in front of a concrete system. This plastic system, if struck from the left, is likely to deflect by a fair amount, and there is a snagging risk at the start of that concrete barrier there. The preferable situation would be to have a direct connection between the two, a continuous longitudinal barrier. Not sure what those concrete barriers are doing there. Part of a scaffold system. We've also got some bollards at play here. Sometimes you do see these energy absorbing bollards used in highly constrained locations where it's not possible to fit a crash cushion or a longitudinal barrier. They're used to provide some level of protection to the hazard behind, but really they should be used as a last resort and only considered in really low speed environments. Here's another instance of where they have been used. A really highly constrained location where there was only a metre or two available to do anything. So a couple of bollards have been installed, and sometimes you do see them installed in a small array. An errant vehicle that leaves the road here, might be slowed to some degree by those bollards before striking the end of that barrier. Probably the arrangement could have been improved, maybe by installing this second one more in front or in line with the barrier. So they are something that can be considered in highly constrained locations as a last resort, but we don't encourage it. A plastic barrier used to separate a pedestrian area from a traffic lane. Pedestrians here are able to walk as close to that barrier as they like. So an impacting vehicle that strikes the barrier will deflect, and if a pedestrian is present, we have a potential safety issue there. And you can see here a barrier has been struck and it's deflected and separated. So in these type of situations, we should be looking at using barriers, concrete or otherwise, that offer a reduced deflection.
Jamie, just on that, I suppose, also the questions come in around, can it be speed dependent, speed limit in the city is 40 and then some of these lower speed environments. So some of the issues that you're presenting, and probably around the energy absorbing bollards is a particular one.
Yeah, certainly they are speed dependent, and each of the products that you've seen, or each of the accepted products are accepted at certain levels, certain test levels. So you need to be mindful of those test levels and how they relate to the speeds at your site. The energy absorbing bollards, I'm not sure, I think they were accepted to perhaps an NCHRP standard up to 50 k's per hour. Stand to be corrected on that. Their best use is in low speed environments like car parks, or perhaps where you've got curbside dining to offer some level of protection to pedestrians and prevent vehicles from manning curbs.
Thank you.
Here's a makeshift barrier terminal. This sort of looks like an ET2000, but certainly wouldn't be able to perform like one. All right, I'm mindful of time and just speeding up a little here. Two different temporary barrier systems combined there that don't appear to be connected directly. There isn't an appropriate length provided in advance of that scaffold. This yellow terminal is a gating arrangement. It is located in front of a curb, which is another issue. I'm not sure how that would perform, but anyone working on that scaffold is certainly not protected by that barrier arrangement. Some more similar examples. This arrangement at first glance sort of looks okay, but from another angle, you can see that that temporary barrier is located at the very top of a significant drop. You do need to be mindful of the deflections of temporary barriers and provide appropriate space between a barrier and an excavation such as this to allow it to perform properly. Some steps have been put into place to overcome some of these typical issues that have been encountered with particularly the installation of proprietary products. A requirement for certificates of compliance came in at one point, and these certificates of compliance are to be completed by the relevant product supplier or their representative. And it required the supplier to visit each and every installation of their product and basically warrant that it had been installed in accordance with their requirements. So as you can imagine, that's sort of quite an onerous requirement on the suppliers, had an impact on the prices of their products. They have some pretty clever apps now that they use, and actually surveillance managers can use to take photos of critical components and submit records of the installation of the products. to verify that they have been done properly. Issues generally or mostly present sort of when products newly come onto the market, and with products like the X350 and the ETSS, there were lots of issues early. The ET2000. Early days there were lots of issues, and over time they reduced. Now we have a new suite of products, so we would expect to see some teething issues with those. There is an accreditation process in the pipeline, a national safety barrier industry accreditation process, and Ken I'm not sure if you can shed any light on this, but a UK company called Lantra has been engaged, and there will be a requirement for barrier designers, barrier installers, and even labourers to have different levels of accreditation under this scheme. Did you have anything to add there on where that process is at?
Yeah, I can add a little bit to that. Before I do that, I might just finish off with this certificate of compliance stuff. There's a couple of comments and questions come in. How does it work now that the installer generally does this and submits it to the supplier? So yeah, it is the taking of critical photos, isn't it? Geotagged, and those then go in. And is there not a conflict of interest in this process? Well, I mean, there is, I suppose, but they're taking on some of the liability, I suppose, with that as well. Any further comments on that, Amy?
No, not really. Look, it was a good sort of educational process for a lot of installers, newer installers to go through. We did some work with one of the suppliers at one point, inspecting a lot of their installations, and there was quite a variety of sort of competency in the industry. And the suppliers, it was a good opportunity for them to engage with installers and provide feedback and help improve their installation processes.
Yeah, I mean, it's interesting. We did that for a while for one of the suppliers, did all their inspections and certificates of compliance. Obviously, yeah, they're just trying to look for ways to streamline processes and keep costs down for all around, which is fair enough. It's what, but we do want to ensure that quality. The other thing is sometimes that the post-opening road safety audits can be a check of that to a degree. It's a bit variable as to your auditor's knowledge of the system and the little components and every little detail, but I think there are good checks and balances in place in Victoria. I think it's something we need to keep working on. In terms of Lantra, as Jamie mentioned, this is sort of the idea being that, like an electrician needs a license to wire up your house, but the person who installs the barrier system doesn't need a license to install that barrier system, and there's complexity, and we've got people's lives at risk there. So the scheme being set up is this national accreditation for industry and licensing of being able to sell products. It's taking a long time. The people are working away on it. We've been approved as a provider of the training for it. We're working with them now to see what credits we can give to people who have successfully completed our pass course, like you all will. We'll see what they provide us with that. But at some point in the future, we hope to be at a point where people are licensed to or have some sort of certification to actually do this. At the moment, it's a bit of a free-for-all.
Thanks, Ken. So when it comes to certificates of compliance, it is a contract requirement in Victoria. There are clauses in VicRoad standard specs for wire open guard fence installation that the licensed supplier must provide those certificates of compliance. Again, just to recap on reference reference material. All barrier installation should be done in accordance with the supplier's requirements and the Austroads, TCUs, and VicRoads guidelines. Some of those are pictured there. A document that we haven't really touched on, Ken mentioned as well, is the Flexible Safety Barrier Installation and Maintenance Guidelines, which is a VicRoads internal document.
I'll put it into Moodle.
Good work. It's for whatever reason, it's not available at the VicRoads website. But it's a great document. It brings together a lot of the common design and installation considerations and issues. And in fact, you'll see a few familiar photos in there if you do get hold of that guideline. So it's a good summary of all those things that you need to be looking out for at the design and installation stages. Any further questions?
Well, one of the questions that came in is how we're going time-wise, and we're going to wrap everything up very shortly as planned. This will be done in about 3 minutes, I reckon. Anybody got any final questions or comments? I'm just going to show you a few things in Moodle so you can finish off the course. But okay, here we go. Hopefully, Jamie, you're seeing Moodle there?
Yep.
Good. Okay, just a couple of final things here. So in the in this reference, so the resources section, reference documents and resources, I put in there. So there's a document there, terminology. So just, there's a lot of terminology. This has got a whole list of terms that were used and what they mean, just in case you need to look something up. You've got the guide, the Austroads guide. You've got a few. There's the maintenance guide that we were just talking about. You've got the RDM, but always do get the most recent one. You got that. You will have hopefully completed quiz 1. If not, go and complete it. You've got to submit it before being able to redo it. If you've got anything wrong, do quiz 2. Upload your barrier product sheet. Very quick little exercise there. Don't spend too long on it. And once you've done all that, you go through. Actually, no quiz for these sessions. So you've got away with no quizzes for today in order to ensure we don't take too much of your time up. So as soon as you've successfully, we've reviewed your barrier product, you complete the course feedback, and hey presto, your certificate of completion will appear. And once you can get it electronically, and then we'll send you that hard copy with some other things to help you out there. So any final questions or comments? So no third test. It was in there. It was taken out because it was to be done in the break, and we don't want you to have to do that. So proving your competency through that first test and the assignment is deemed sufficient. Any other questions or comments? Well, thank you very much for taking time out of your busy schedules to get some fundamentals of barriers. We tried to cover across a massive spectrum of stuff at a fairly shallow level. We will let you know of day 2 and 3 when the world allows us to get together in an area and go out and design up barriers and have further in depth. So hopefully you'll come along to that at some point. Thank you, Jamie. Always good to get your immense technical knowledge shared. If anybody has any problems struggling with the assignment or anything like that, get in contact with me. you've got my contact details there, many different ways, or call Safe System Solutions office or jump on our website and you can get my phone number, and we can ensure that you get through that. I'm sure you'll do pretty well. Otherwise, yeah, but if you do have any sort of spot barrier questions, always happy to have a chat. And Jamie is the same, and you've got our contact details. If it's a particular one, will the Department of Transport approve this alteration? We can't help you there. We're a private company, but that's where Evan is your man to go to for that approval. So apart from that, let's keep getting that barrier out there, saving lives with it, but let's get it out there in the best possible way. And yeah, no need to even count the wallies because there's not a quiz, but we kept you engaged and interested anyway. Thank you very much, everybody. Pretty much everybody got a prize, I think, and if you didn't, you're probably going to get a prize anyway because we are packing the prize packs and maybe 1 or 2 extra for those who got a few prizes. Thank you very much, and see you at the next course.
Thanks, everyone.